Do you know the history and quality of the top foods on your favorite food list? Today, we bring you one of the most vibrant, versatile, and universally beloved vegetables, or rather, fruits, that has ever graced the kitchens of the world. This is the extraordinary, colorful, and deeply fascinating story of the bell pepper. Please let us know in the comments where you are watching this history video and what time you are watching it. And be sure to subscribe to our channel for more history videos in the future. Now let us begin. When you walk through a grocery store, a farmer's market, or even a roadside stand, there are few sights as instantly captivating as a pile of bell peppers. Green ones stacked beside brilliant reds, golden yellows shining like small lanterns, deep, rich oranges that look almost too beautiful to eat. And sometimes, if you are lucky, you will spot the rare purple, the chocolate brown, or the ivory white. Bell peppers are a feast for the eyes long before they ever become a feast for the palate. But how many of us have ever truly stopped to wonder, where did this remarkable food come from? Who first discovered it? How did it travel from its place of origin to become one of the most consumed vegetables on the entire planet? And what secrets does it hold inside its crisp, hollow walls? Secrets of nutrition, of healing, of culinary magic. The story of the bell pepper is not a short one. It stretches back thousands upon thousands of years, weaving through ancient civilizations, colonial conquests, trade routes that spanned oceans, and scientific discoveries that changed how we understand food itself. It is a story of nature's genius and humanity's curiosity, and it begins in a land of jungles, mountains, and rivers, in the heart of central and south regions of the Western Hemisphere. Long before recorded history, long before the first empires rose and fell, wild pepper plants grew in the tropical and subtropical regions of central and south lands in the Western Hemisphere. These were not the large, blocky, sweet bell peppers we know today. No, these were small, fiery wild fruits, tiny pods bursting with heat, clinging to scraggly bushes under the canopy of dense tropical forests. Scientists believe that the genus Capsicum, the family to which all peppers belong, originated somewhere in the region that we now associate with modern-day Bolivia and southern Brazil. From there, birds, yes, birds, played a critical role in spreading pepper seeds across a vast geographic area. You see, birds are immune to the chemical capsaicin, the compound that gives hot peppers their burning sensation. Mammals, on the other hand, feel that burn intensely. This was nature's ingenious strategy. The pepper plant did not want mammals grinding its seeds to pulp with their flat molars. Instead, it wanted birds to eat the fruit whole, fly great distances, and deposit the seeds intact and ready to germinate in new locations, wrapped in a neat package of natural fertilizer. And so, over millions of years, wild capsicum species spread throughout the tropical regions, diversified, and adapted to different climates, altitudes, and soil types. The earliest evidence of humans interacting with peppers dates back an astonishing 9,000 years. Archaeological excavations in regions spanning from the highlands of the Andes to the lowland river valleys of the tropics have uncovered traces of pepper residue on ancient pottery, grinding stones, and cooking implements. These early humans were not yet farmers. They were hunter-gatherers, foraging through the forests, collecting wild fruits, roots, tubers, and yes, wild pepper pods. It is believed that they initially used these wild peppers not primarily as food, but as medicine and possibly as a preservative. The intense heat of the wild pepper had antimicrobial properties, and ancient peoples, though they did not understand microbiology, certainly observed that food stored with crushed peppers lasted longer and was less likely to cause illness. Somewhere between 7,000 and 5,000 years ago, a monumental shift occurred. Humans in Mesoamerica and in the Andean regions began to domesticate the pepper plant. This was part of a broader agricultural revolution, the same wave of innovation that saw the domestication of maize, squash, beans, and other foundational crops. Domestication is a slow, painstaking process. Generation after generation, early farmers selected the plants with the most desirable traits, larger fruits, more predictable growth patterns, resistance to certain pests, and saved their seeds for the next planting season. Over centuries, this selective pressure transformed the wild capsicum into something recognizably different from its ancestors. 5 major species of domesticated capsicum eventually emerged from this long process. Capsicum annuum, the species that includes the bell pepper, became the most widespread and commercially important. Capsicum frutescens gave the world the Tabasco pepper. Capsicum chinense produced the habanero and its fiery relatives. Capsicum bicatum became popular in south regions, and Capsicum pubescens, adapted to cooler highland climates, produced the ricotta pepper. Each of these species represents a different lineage of domestication, a different group of ancient people making independent decisions about which traits to favor in their pepper plants. But it is Capsicum annuum that concerns us most today. Within this single species lies an extraordinary range of diversity. From the mildest, sweetest bell pepper to the scorching cayenne, from the smoky poblano to the piquant jalapeno, all are members of the same species. They are as closely related as a Great Dane is to a Chihuahua, and among all of them the bell pepper stands unique. It is the only widely cultivated pepper that produces virtually no capsaicin. It is, in essence, a pepper that forgot how to be hot. How did this happen? The answer lies in a single recessive gene. At some point in the long history of pepper domestication, a mutation occurred in a gene responsible for capsaicin production. When this mutation was present in both copies of the gene, when a plant was homozygous for this recessive trait, capsaicin production was effectively shut off. The result was a pepper that had all the flavor, all the crunch, all the sweetness of its relatives, but none of the heat. Ancient farmers who encountered this mutant must have recognized its value immediately. Here was a pepper that could be eaten in large quantities without discomfort, a pepper that children and elders could enjoy, a pepper that could serve as a vegetable rather than merely a spice. They saved its seeds, they cultivated it, and over time, the sweet, non-pungent bell pepper became a crop in its own right. The ancient civilizations of Mesoamerica held the pepper in extraordinarily high regard. The Maya, whose sophisticated civilization flourished for centuries in the tropical lowlands of what is now southeastern Mexico, Guatemala, Belize, and Honduras, used peppers extensively in their cuisine, their medicine, and their religious rituals. Mayan texts and carvings depict peppers alongside cacao, maize, and other sacred foods. Peppers were offerings to the gods. They were ingredients in ceremonial beverages. They were tools of punishment. It is recorded that misbehaving children were sometimes held over the smoke of burning peppers as a form of discipline, the capsaicin-laden smoke stinging their eyes and nose. The Aztecs, whose powerful empire dominated central Mesoamerica in the centuries before European contact, were equally devoted to the pepper. The Nahuatl language spoken by the Aztecs had an incredibly detailed vocabulary for peppers, with specific names for dozens of varieties distinguished by size, shape, color, heat level, and culinary application. The Aztec marketplaces, the famous Tianguistli, were vibrant, sprawling affairs where peppers of every description were traded in enormous quantities. Aztec cuisine was complex and varied, and peppers were foundational to it. They were used fresh, dried, smoked, ground into pastes, and blended into sauces. The Aztecs made a drink called chilitol, a thick, spiced beverage combining ground maize with chili peppers. They made elaborate moles and salsas, and they recognized different peppers for different purposes, some for everyday cooking, some for feasting, some for medicinal applications. Among the many pepper varieties cultivated by the Aztecs and other Mesoamerican peoples, sweet varieties, ancestors of what we would eventually call bell peppers, were known and valued. These mild peppers were stuffed, roasted, and eaten as a substantial part of the meal, not merely as a flavoring agent. Their large, thick-walled fruits made them ideal for stuffing with mixtures of grains, beans, and other ingredients. This tradition of stuffing peppers is ancient, far older than most people realize, and it persists to this day in kitchens around the globe. The Inca Empire, stretching along the western spine of South lands, also had a deep relationship with the pepper. The Incas cultivated multiple species and varieties of capsicum, integrating them into their agricultural system alongside potatoes, quinoa, and maize. Peppers were dried and traded across vast distances using the Inca road system, one of the most impressive engineering achievements of the ancient world. The Quechua word for pepper, achu, appears frequently in Inca records, and peppers were so valued that they sometimes served as a form of currency or tribute. Now, let us move forward in time to one of the most consequential moments in the history of food, and indeed in the history of the world. In 1492, Christopher Columbus set sail from Spain, seeking a westward sea route to the spice-rich lands of Asia. He was looking, among other things, for black pepper, Piper nigrum, one of the most valuable commodities in the medieval world. Black pepper, native to South Asia, had been traded across the globe for centuries, and it commanded astronomical prices in European markets. Whoever could find a cheaper, more direct route to the source of black pepper would gain an enormous economic advantage. Columbus, as we know, did not reach Asia. He landed in the Caribbean, in a world entirely unknown to Europeans, and there, among the many unfamiliar plants, animals, and peoples he encountered, he found peppers. Not the black pepper he was seeking, not Piper nigrum at all, but capsicum peppers, an entirely unrelated plant that happened to produce a pungent, spicy sensation. Columbus, eager to justify his voyage to his royal sponsors, Ferdinand and Isabella of Spain, called these new plants peppers because of their spicy taste, deliberately conflating them with the valuable black pepper of Asia. It was a marketing decision, essentially, and the misnomer stuck. To this day, we call capsicum fruits peppers, even though they have no botanical relationship whatsoever to true pepper, Piper nigrum. Columbus brought capsicum seeds back to Spain on his return voyage in 1493. This was one of the first acts in what historians call the Columbian exchange, the massive, unprecedented transfer of plants, animals, diseases, and ideas between the eastern and western hemispheres. The Columbian exchange would reshape the world's ecosystems, cuisines, and populations in ways that are still unfolding today. And the pepper was one of its earliest and most successful travelers. The Spanish court received these new peppers with curiosity. Initially, they were grown as ornamental plants in monastery gardens and the gardens of the nobility. Their bright, colorful fruits were considered decorative, beautiful curiosities from the New World. But it did not take long for people to begin eating them. The spicy varieties were quickly recognized as a cheap, locally growable substitute for the expensive imported black pepper and other Asian spices. For the first time, ordinary Europeans could add heat and pungency to their food without spending a fortune. This was revolutionary. Spices had been luxury goods for centuries, symbols of wealth and status. Now, suddenly, any farmer with a sunny patch of ground could grow their own. From Spain, pepper seeds spread rapidly. Portuguese traders, who had their own extensive networks of colonies and trading posts stretching from Brazil to Africa to India to Southeast Asia, were instrumental in this dispersal. The Portuguese carried capsicum seeds to their colonies in West Africa, East Africa, India, and the Malay archipelago within just a few decades of Columbus's initial discovery. The speed of this spread is remarkable. By the mid-1500s, barely 50 years after Columbus, capsicum peppers were being cultivated across vast swaths of Africa, Asia, and Europe. The reception of peppers varied enormously from culture to culture. In many parts of Asia and Africa, hot peppers were embraced with extraordinary enthusiasm. They slotted perfectly into existing culinary traditions that already valued pungent, spicy flavors. In India, peppers were adopted so quickly and so thoroughly that within a few generations, many people had forgotten that they were a foreign introduction. Today, it is almost impossible to imagine Indian cuisine without chili peppers, yet they have been present on the subcontinent for only about 500 years, a blink of an eye in the long history of Indian cooking. In Europe, the reception was more mixed. Southern European cuisines, Spanish, Portuguese, Italian, and to some extent, the cuisines of the Ottoman Empire and Hungary embraced peppers more readily than those of Northern Europe. The Hungarian adoption of the pepper is particularly noteworthy. Peppers arrived in Hungary through the Ottoman Empire, probably in the 16th or 17th century. Hungarian farmers developed their own distinctive varieties, and the ground-dried pepper, paprika, became the defining spice of Hungarian cuisine. Today, Hungary is one of the world's most famous paprika-producing regions, and dishes like goulash and chicken paprikash are unthinkable without it. But what about the bell pepper specifically, the sweet, mild, non-pungent variety? Its story within this broader narrative of global pepper dispersal is somewhat distinct. While hot peppers were valued primarily as spices, as flavoring agents used in relatively small quantities, the sweet bell pepper was valued as a vegetable, consumed in much larger amounts and appreciated for its crisp texture, mild flavor, and versatility in the kitchen. The development of the modern bell pepper as we know it today, large, blocky, thick-walled, and available in a rainbow of colors, is largely a product of selective breeding that intensified in the 18th, 19th, and 20th centuries. European gardeners and farmers, working with the genetic diversity present in the seeds that had arrived from the Western Hemisphere, gradually selected for the traits that would define the modern bell pepper. They wanted larger fruits. They wanted thicker walls, which would give the pepper a more satisfying crunch and make it easier to stuff. They wanted a more uniform shape, which would make the peppers easier to pack and transport. And they wanted sweetness, a rich, fruity sweetness that would make the bell pepper appealing as a raw snack, a salad ingredient, and a cooked vegetable. This selective breeding was not the work of a single genius or a single institution. It was the cumulative effort of thousands of anonymous gardeners and farmers across centuries, each making small improvements, each saving seeds from their best plants. Seed catalogs from the 18th and 19th centuries show a gradually expanding selection of sweet pepper varieties, and by the early 20th century, the bell pepper had essentially assumed its modern form. The name bell pepper itself is descriptive. These peppers are often shaped like a bell, with a broad, rounded body tapering slightly at the bottom. But bell peppers go by many names around the world. In many countries, they are called sweet peppers or capsicums. In parts of Europe, they are known as paprika, the same word used for the dried, ground spice, which can cause some confusion. In various languages, they have names that translate to garden pepper, sweet pepper, large pepper, or simply pepper. The diversity of names reflects the diversity of cultures that have adopted this remarkable fruit. Let us now turn our attention to the biology of the bell pepper, because understanding how this plant grows and reproduces helps us appreciate the food on our plates even more deeply. The bell pepper plant, Capsicum annuum, is a member of the family Solanaceae, the nightshade family. This is a large and important plant family that includes some of the world's most significant food crops, tomatoes, potatoes, and eggplants, as well as some notorious poisonous plants, such as deadly nightshade or belladonna. The association with poisonous relatives initially made some Europeans wary of eating peppers, just as it made them suspicious of tomatoes and potatoes. But those fears were eventually overcome by the undeniable deliciousness of these foods. The bell pepper plant is a short-lived perennial in its native tropical environment, but is typically grown as an annual in temperate climates. It grows as a bushy, upright plant, usually reaching a height of about 1 to 3 feet, though some vigorous varieties can grow taller under ideal conditions. The stems are somewhat woody at the base and become more herbaceous toward the growing tips. The leaves are simple, alternate, and dark green with a slightly glossy surface. They are generally oval to lance-shaped, and they provide a lush canopy that helps shade the developing fruits from intense sunlight. The flowers of the bell pepper are small, white, and star-shaped with 5 or 6 petals. They are typically self-pollinating, meaning that each flower contains both male and female reproductive structures and can pollinate itself without the help of insects or wind. However, cross-pollination by bees and other insects does occur and can increase fruit set and yield. This is an important consideration for gardeners and farmers, providing pollinator habitat near pepper fields can improve harvests. After successful pollination, the flower's ovary begins to swell and the fruit develops. A bell pepper fruit is technically a berry, a fleshy fruit with seeds embedded in the interior. The fruit wall, known as the pericarp, is thick and crisp in bell peppers, much thicker than in most hot pepper varieties. The interior of the fruit is mostly hollow, divided by thin pale membranes called septa, which connect to a central column of tissue called the placenta. The seeds are attached to the placenta and the upper portions of the septa. In hot peppers, the placenta is the primary site of capsaicin production. It is the white, spongy tissue near the seeds that carries the most heat. In bell peppers, this tissue is present but produces little to no capsaicin, thanks to that crucial recessive gene mutation we discussed earlier. The color of a bell pepper is determined by its stage of ripeness and its specific variety. This is one of the most commonly misunderstood aspects of bell peppers, so let us clarify it thoroughly. Green bell peppers are simply unripe bell peppers. They have been harvested before they have reached their full maturity. If left on the plant, a green bell pepper will eventually change color, usually to red, but sometimes to yellow, orange, purple, chocolate brown, or even ivory white, depending on the variety. This means that in most cases, a red bell pepper and a green bell pepper can come from the exact same plant. The red one was simply allowed to ripen longer. This extended ripening time has significant implications for both flavor and nutrition. As the pepper ripens, its sugar content increases, making it sweeter. Its vitamin content also changes. Ripe peppers have significantly higher levels of certain vitamins than their unripe green counterparts. However, allowing peppers to ripen on the plant also means a longer growing period and a greater risk of loss to weather, pests, and disease, which is why green bell peppers are typically less expensive than their colorful, fully ripe counterparts. Yellow and orange bell peppers come from varieties that have been specifically bred to ripen to those colors rather than red. These varieties have different pigment profiles. They produce high levels of yellow and orange carotenoids rather than the red pigment lycopene. Purple bell peppers get their color from anthocyanins, the same pigments found in blueberries, red cabbage, and purple grapes. Interestingly, the purple color in most purple bell pepper varieties is only skin deep. If you cut one open, the flesh inside is typically green. And if you cook a purple bell pepper, the heat often destroys the anthocyanins, causing the pepper to turn green or olive in color. Chocolate or brown bell peppers are another interesting variant. Their unusual color is the result of a combination of red pigments and residual green chlorophyll, which together create a brownish hue. White or ivory bell peppers lack most of the typical pigments, resulting in a pale, almost ghostly appearance that can be quite striking in a mixed pepper display. Now, let us delve into the nutritional profile of the bell pepper, because this is where the story becomes truly extraordinary. Bell peppers are nutritional powerhouses, and that is not an exaggeration. For a food that is about 92% water and contains very few calories, the bell pepper packs an astonishing punch of vitamins, minerals, and beneficial plant compounds. Let us start with vitamin C, because this is where the bell pepper truly shines. Most people, when asked to name the best food source of vitamin C, will say oranges or citrus fruits. They are wrong. Bell peppers, particularly red bell peppers, contain far more vitamin C per serving than oranges. A single medium-sized red bell pepper can contain over 200% of the recommended daily intake of vitamin C. This makes the red bell pepper one of the single best food sources of this essential vitamin on the entire planet. The discovery of vitamin C in peppers has its own fascinating history. In the early 20th century, a Hungarian biochemist named Albert Szent-Györgyi was researching the chemical processes of cellular respiration. In the course of his work, he isolated a substance from the adrenal glands of animals that he initially called hexuronic acid. He suspected it might be the elusive anti-scurvy factor that scientists had been seeking for decades, the vitamin that prevented the dreaded disease of scurvy, which had plagued sailors and explorers for centuries. Shentgyarji needed a large quantity of this substance for his research, and animal adrenal glands were difficult and expensive to obtain in sufficient quantities. Then, in a stroke of genius, or perhaps lucky inspiration, he turned to the Hungarian paprika pepper. Hungary, as we have discussed, had a long and proud tradition of pepper cultivation, and Shentgyarji realized that peppers might be a rich source of his mysterious substance. He was right. Peppers, particularly the ripe red varieties, proved to be extraordinarily rich in hexuronic acid, which was soon renamed ascorbic acid. Vitamin C. Shentgyarji was able to extract large quantities of pure vitamin C from Hungarian peppers, enabling him to characterize its chemical structure and biological function. For this work, he was awarded the Nobel Prize in Physiology or Medicine in 1937. It is no exaggeration to say that the bell pepper played a crucial role in one of the most important nutritional discoveries of the 20th century. But vitamin C is just the beginning. Bell peppers are also an excellent source of vitamin A, primarily in the form of beta-carotene, which the body converts to vitamin A as needed. Vitamin A is essential for healthy vision, immune function, and skin health. Red and orange bell peppers are particularly rich in beta-carotene, which also functions as a powerful antioxidant in its own right. Bell peppers contain significant amounts of vitamin B6, also known as pyridoxine, which plays a vital role in brain development, immune function, and the metabolism of proteins and amino acids. They are a good source of vitamin K1, which is essential for proper blood clotting and bone health. They contain vitamin E, a fat-soluble antioxidant that protects cell membranes from oxidative damage. They provide folate, also known as vitamin B9, which is particularly important for pregnant women because of its role in preventing neural tube defects in developing fetuses. The mineral content of bell peppers, while not as dramatic as their vitamin content, is nonetheless noteworthy. Bell peppers contain potassium, which helps regulate blood pressure and fluid balance. They provide small but meaningful amounts of manganese, which is involved in bone formation and metabolism. They contain magnesium, phosphorus, and iron in modest quantities, but perhaps the most exciting nutritional story of the bell pepper lies in its phytochemical content, the diverse array of plant compounds that are not technically vitamins or minerals, but that have profound effects on human health. Bell peppers are rich in carotenoids, plant pigments that function as antioxidants. The specific carotenoid profile varies with the color of the pepper. Red bell peppers are rich in lycopene and beta-carotene. Orange bell peppers are high in beta-carotene, alpha-carotene, and zeaxanthin. Yellow bell peppers contain high levels of violexanthin, lutein, and zeaxanthin. Green bell peppers contain lutein and beta-carotene, though in lower quantities than their ripe counterparts. Lutein and zeaxanthin deserve special mention because they are specifically important for eye health. These carotenoids accumulate in the macula, the central part of the retina responsible for sharp, detailed vision, where they act as natural sunglasses, filtering out harmful high-energy blue light and protecting the delicate photoreceptor cells from oxidative damage. Research has shown that diets rich in lutein and zeaxanthin are associated with a reduced risk of age-related macular degeneration and cataracts, two of the leading causes of vision loss in older adults. Bell peppers also contain quercetin, a flavonoid with potent anti-inflammatory and antioxidant properties. Quercetin has been studied extensively for its potential role in reducing the risk of heart disease, cancer, and neurodegenerative disorders. While much of this research is still in early stages, the presence of quercetin in bell peppers adds another layer to their already impressive nutritional resume. Luteolin is another flavonoid found in bell peppers, and it has been studied for its anti-inflammatory, anti-allergic, and potentially anti-cancer properties. Research suggests that luteolin may help inhibit the growth of certain types of cancer cells in laboratory settings, though more research is needed to determine whether these effects translate to meaningful cancer prevention in humans. The fiber content of bell peppers is modest but meaningful. A medium-sized bell pepper contains about 2 to 3 grams of dietary fiber, which contributes to digestive health, helps regulate blood sugar levels, and promotes feelings of fullness after eating. The fiber in bell peppers is a mix of soluble and insoluble types, providing benefits for both the upper and lower digestive tract. Now let us talk about the health benefits of bell peppers in more detail, because the nutritional profile we have just described translates into some truly remarkable effects on human health. The antioxidant content of bell peppers, the combination of vitamin C, vitamin E, beta-carotene, and various flavonoids and carotenoids, makes them a potent weapon against oxidative stress. Oxidative stress occurs when there is an imbalance between the production of free radicals, unstable, highly reactive molecules, and the body's ability to neutralize them with antioxidants. When free radicals accumulate, they can damage DNA, proteins, and cell membranes, contributing to aging, inflammation, and the development of chronic diseases including heart disease, cancer, and neurodegenerative disorders. By providing a rich and diverse supply of antioxidants, bell peppers help tip the balance back in favor of cellular health. The vitamin C in bell peppers is a water-soluble antioxidant that works in the aqueous environment of cells and body fluids. The vitamin E is a fat-soluble antioxidant that protects cell membranes. The carotenoids work in both aqueous and lipid environments. Together, they provide comprehensive antioxidant protection that spans the full range of cellular compartments. The cardiovascular benefits of bell peppers are substantial and well documented. The potassium in bell peppers helps regulate blood pressure by counteracting the effects of sodium. The fiber helps manage cholesterol levels by binding to bile acids in the digestive tract and promoting their excretion. The antioxidants protect LDL cholesterol particles from oxidation, a critical step in the development of atherosclerosis, the buildup of fatty plaques in the arteries that can lead to heart attacks and strokes. The folate in bell peppers helps regulate homocysteine levels. Elevated homocysteine is a risk factor for cardiovascular disease. The anti-inflammatory properties of bell peppers are another important health benefit. Chronic low-grade inflammation is now recognized as a driving force behind many of the most common and deadly diseases of the modern era, including heart disease, type 2 diabetes, cancer, and Alzheimer's disease. The quercetin and other flavonoids in bell peppers have been shown to inhibit the production of inflammatory cytokines and enzymes, potentially helping to quell the fires of chronic inflammation. For eye health, as we mentioned earlier, the lutein and zeaxanthin in bell peppers provide specific, targeted protection for the macula. But the benefits extend beyond just these two carotenoids. The vitamin C in bell peppers helps maintain the health of blood vessels in the eye, and the vitamin A supports the function of the retina and the health of the cornea. Eating bell peppers regularly is, in essence, feeding your eyes exactly what they need to stay healthy and functional. Bell peppers may also play a role in cancer prevention, though this is an area where we must be careful to distinguish between promising research and proven clinical outcomes. Laboratory studies have shown that various compounds in bell peppers, including quercetin, luteolin, and certain carotenoids, can inhibit the growth of cancer cells, induce apoptosis, programmed cell death in cancer cells, and reduce the formation of new blood vessels that tumors need to grow. Population studies have found associations between higher consumption of fruits and vegetables rich in these compounds and lower rates of certain cancers. However, it is important to note that no single food can prevent cancer on its own, and the overall pattern of diet and lifestyle is far more important than any individual food. The benefits of bell peppers for skin health are also noteworthy. Vitamin C is essential for the production of collagen, the the structural protein that gives skin its firmness and elasticity. As we age, collagen production naturally declines, leading to wrinkles, sagging, and other signs of aging. By providing abundant vitamin C, bell peppers support the body's ability to produce collagen and maintain youthful, healthy skin. The antioxidants in bell peppers also protect the skin from damage caused by ultraviolet radiation and environmental pollutants. Bell peppers support immune function through multiple mechanisms. Vitamin C is perhaps the most well-known immune-supporting nutrient, and bell peppers provide it in abundance. Vitamin C enhances the production and function of white blood cells, the immune system's frontline soldiers. It also acts as an antioxidant within immune cells, protecting them from the oxidative damage they can sustain during the process of fighting infections. Vitamin A, provided by the beta-carotene in bell peppers, is essential for maintaining the integrity of mucosal surfaces, the linings of the respiratory tract, digestive tract, and other body surfaces that serve as barriers against infection. Vitamin B6 supports the biochemical reactions involved in immune cell production and communication. For those managing their weight, bell peppers are an ideal food. They are extremely low in calories. A medium-sized bell pepper contains only about 30 to 40 calories, yet they are substantial enough to contribute to feelings of fullness and satisfaction. Their high water content and fiber content help slow digestion and prolong satiety. Their natural sweetness can satisfy cravings for sugary foods without the blood sugar spikes that come with refined sweets. And their versatility in the kitchen means they can be incorporated into an almost infinite variety of dishes, from salads to stir-fries to soups to snacks, keeping meals interesting and preventing the boredom that often derails weight management efforts. The glycemic index of bell peppers is very low, making them an excellent food choice for people with diabetes or those at risk of developing diabetes. The glycemic index is a measure of how quickly a food raises blood sugar levels after eating. Foods with a low glycemic index cause a slow, gradual rise in blood sugar, while foods with a high glycemic index cause a rapid spike. Bell peppers, with their low sugar content, high fiber content, and high water content, have a glycemic index that is among the lowest of any food. This means they can be eaten freely by people who need to carefully manage their blood sugar levels. The digestive benefits of bell peppers extend beyond their fiber content. Bell peppers contain water and certain compounds that may help stimulate the production of gastric juices, aiding in the digestion of food. However, some individuals may find that raw bell peppers are difficult to digest, particularly those with sensitive stomachs or conditions like irritable bowel syndrome. The skin of the bell pepper, while nutritious, contains cellulose, a tough, indigestible fiber that can be challenging for some digestive systems. Cooking bell peppers softens the cellulose and makes them easier to digest, though it may reduce some heat-sensitive nutrients like vitamin C. Let us now return to the historical narrative and trace the bell pepper's journey through the centuries as it became a global staple. After the initial introduction of peppers to Europe in the late 15th and early 16th centuries, the spread of capsicum around the world accelerated rapidly through the 16th and 17th centuries. The Portuguese, as we mentioned, were particularly important in this process. Their trading empire stretched from Brazil in the west to Macau and Nagasaki in the east, and they carried pepper seeds to virtually every port where their ships dropped anchor. In Africa, peppers were adopted with remarkable speed. The Portuguese introduced them to their trading posts and colonies along the West African coast, and from there, they spread rapidly through indigenous trade networks. Within a few generations, peppers had become integral to West African cuisines, where they complemented existing spice traditions that included grains of paradise, cubeb pepper, and other locally grown pungent plants. Today, many West African dishes are built around a foundation of hot peppers, and bell peppers are widely used in stews, soups, and rice dishes across the continent. In East Africa, peppers arrived via both the Portuguese sea route and overland trade routes from the Middle East and North Africa. Ethiopian cuisine, which has its own ancient spice traditions centered on the Berber spice blend, incorporated peppers enthusiastically. The Berber blend itself, now considered quintessentially Ethiopian, includes dried peppers as a primary ingredient, a testament to how thoroughly this New World crop was integrated into one of the oldest culinary traditions on Earth. In India, the adoption of capsicum peppers was perhaps the most dramatic and consequential of all. Before the arrival of capsicum, Indian cuisine used black pepper, long pepper, and ginger to provide heat and pungency. These were effective but relatively expensive, particularly black pepper, which was a major trade commodity. The arrival of capsicum peppers, which grew easily in the Indian climate, produced abundantly, and provided intense heat at minimal cost, was transformative. Within a remarkably short time, capsicum peppers had penetrated every regional cuisine of the subcontinent, from the vindalus of Goa, a dish whose name itself reflects the Portuguese colonial influence, to the fiery curries of Andhra Pradesh and the subtle vegetable dishes of Gujarat. The bell pepper, or capsicum as it is commonly called in South Asia, also found a place in Indian cuisine, though it never achieved the same dominance as the hot varieties. Bell peppers are used in stir-fries, curries, and rice dishes, and they are particularly popular in Indo-Chinese fusion cuisine, a unique culinary tradition that blends Indian and Chinese cooking techniques and flavors. In Southeast Asia, peppers arrived through multiple routes: Portuguese and Spanish traders, Chinese merchants, and eventually Dutch and British colonial traders. Thai cuisine, which is now famous for its bold, spicy flavors, was profoundly shaped by the introduction of capsicum peppers. Before their arrival, Thai cooks relied on native galangal, black pepper, and other local spices for heat. The arrival of chili peppers unleashed an explosion of culinary creativity, leading to the development of the iconic Thai curry pastes, som tam, green papaya salad, and countless other dishes that define Thai cuisine today. In East Asia, peppers arrived somewhat later than in South and Southeast Asia, but their impact was no less significant. In Korea, peppers became the basis of gochugaru, dried, ground red pepper flakes, which is the essential ingredient in kimchi, the fermented vegetable dish that is arguably the national food of Korea. Before the arrival of capsicum peppers, kimchi was made without red pepper, and historical records suggest it was a rather different dish from what we know today. In China, peppers were adopted with particular enthusiasm in the inland provinces of Sichuan, Hunan, Guizhou, and Yunnan, where they complemented existing spice traditions and became defining features of regional cuisines. In Japan, peppers arrived via Portuguese traders who had established a trading post at Nagasaki. The Japanese cultivated peppers and developed their own varieties, including the shishito pepper and the mild, sweet fushimi pepper. While Japanese cuisine is not generally associated with intense spiciness, peppers have a recognized and valued place in the Japanese culinary repertoire, used in condiments like shichimi togarashi, 7-spice powder, and as vegetables in tempura, stir-fries, and grilled preparations. In the Middle East, peppers integrated into a culinary landscape that already featured a rich tradition of using vegetables, herbs, and spices. Stuffed peppers became a beloved dish across the Eastern Mediterranean and the Levant, with recipes varying from country to country and family to family. Turkish, Lebanese, Syrian, and Egyptian cuisines all feature stuffed peppers prominently, typically filled with a mixture of rice, minced meat, herbs, and spices. The bell pepper, with its large cavity and sturdy walls, was perfectly suited to this application, and it quickly became one of the most popular vegetables for stuffing. In the Mediterranean basin, bell peppers found particularly fertile ground, both literally and figuratively. The warm, sunny climate of the Mediterranean region was ideal for growing peppers, and the culinary traditions of the region, which already celebrated the vegetable garden and the bounty of the earth, were perfectly positioned to embrace this new crop. Spanish cuisine developed a deep relationship with peppers, giving rise to dishes like pisto, a vegetable stew similar to ratatouille, escalivada roasted vegetables, and the famous pimientos de padron small green peppers, usually mild but occasionally hot, seared in olive oil and sprinkled with coarse salt. Italian cuisine adopted peppers with equal enthusiasm. Peperonata, a slow-cooked mixture of bell peppers, onions, tomatoes, and olive oil, became a classic Italian side dish. Stuffed peppers, roasted peppers, marinated peppers, and peppers preserved in oil and vinegar became standard elements of the Italian pantry. The Italian word pepperone, plural pepperoni, refers to bell peppers, which is why the sausage topping known as pepperoni in some countries takes its name from the Italian word for pepper, reflecting the pepper or paprika used in its seasoning. In France, bell peppers became an important ingredient in the cuisine of Provence, the sun-drenched southern region where the cooking philosophy emphasizes fresh, local, seasonal vegetables prepared simply to highlight their natural flavors. Ratatouille, the iconic Provençal vegetable stew, features bell peppers prominently alongside tomatoes, eggplant, zucchini, onions, and herbs. The Basque Country, straddling the border between France and Spain, developed its own distinctive pepper culture, including the famous Espelette pepper, a mildly hot pepper that is dried and ground into a spice that has earned protected designation of origin status. As bell peppers spread across the globe, different cultures developed different preferences and different uses for them. Some favored the green bell pepper for its slightly bitter, vegetal flavor and its firm texture. Others preferred the fully ripe red pepper for its sweetness and higher nutrient content. Some cultures used bell peppers primarily as a cooked ingredient, while others enjoyed them raw. Some traditions emphasized stuffing and roasting, while others focused on slicing and stir-frying. This diversity of culinary applications is one of the bell pepper's greatest strengths. It is a remarkably adaptable ingredient that fits comfortably into almost any culinary tradition. Let us now turn our attention to the cultivation of bell peppers, the art and science of growing these wonderful plants from seed to harvest. Bell peppers are warm season crops that thrive in conditions similar to those of their tropical ancestors. They need warmth, sunlight, and consistent moisture, and they are intolerant of frost. In temperate climates, bell peppers are typically started indoors from seed, well before the last frost date, and then transplanted outdoors once the soil has warmed and the risk of frost has passed. The ideal temperature range for bell pepper growth is between 70 and 85 degrees Fahrenheit. Below 60 degrees, growth slows dramatically, and prolonged exposure to temperatures below 50 degrees can cause chilling injury, which manifests as wilting, yellowing, and poor fruit set. Above 95 degrees, pepper plants may drop their flowers without setting fruit, a phenomenon known as blossom drop, because the high temperatures can damage pollen viability. This sensitivity to temperature extremes means that bell peppers perform best in areas with warm but not excessively hot summers, or in controlled environments like greenhouses and high tunnels. Sunlight is essential for bell pepper production. The plants need at least 6 to 8 hours of direct sunlight per day to produce a good crop of fruit. In regions with intense, unrelenting summer sun, some light afternoon shade can actually be beneficial, reducing heat stress and the risk of sunscald on the fruit. Sunscald is a condition in which the skin of the pepper is damaged by direct, intense sunlight, creating pale, papery patches that are susceptible to decay. Maintaining adequate leaf cover over the developing fruits is one of the best defenses against sunscald. Soil requirements for bell peppers are moderate. They prefer a well-drained, loamy soil with a pH between 6 and 7, slightly acidic to neutral. Heavy clay soils can cause waterlogging and root problems, while very sandy soils may not retain enough moisture and nutrients. Adding organic matter, compost, well-rotted manure, or leaf mold to the soil before planting can improve its structure, drainage, and nutrient-holding capacity, benefiting bell peppers regardless of the initial soil type. Watering is a critical aspect of bell pepper cultivation. The plants need consistent, even moisture throughout the growing season. Drought stress can cause blossom drop, reduced fruit size, and a condition called blossom end rot, a dark, sunken area on the bottom of the fruit that is caused not by a pathogen but by a calcium deficiency triggered by inconsistent watering. When the soil alternates between very wet and very dry, the plant's ability to absorb calcium is disrupted, even if there is adequate calcium in the soil. The result is a breakdown of cell walls in the developing fruit, producing the characteristic dark, leathery lesion. Mulching around pepper plants helps maintain consistent soil moisture, reduce weeds, and moderate soil temperature. Fertilization is another important consideration. Bell peppers are moderate feeders that benefit from a balanced supply of nutrients. Too much nitrogen can produce lush, leafy plants that set relatively few fruits. A balanced fertilizer with adequate phosphorus and potassium, in addition to nitrogen, will promote both healthy vegetative growth and good fruit production. Many experienced growers apply a balanced fertilizer at planting time and then side dress with additional fertilizer once the first fruits begin to set. The growing season for bell peppers varies depending on the variety and the climate, but most bell peppers take between 60 and 90 days from transplanting to reach the green, harvestable stage. If the grower wants fully ripe, colored peppers, additional time is needed, typically an extra 2 to 4 weeks beyond the green stage. This extended growing season for colored peppers is one reason why they are more expensive than green peppers at the market. The plants must be maintained, watered, and protected for a longer period, and there is a greater window of time during which the crop can be lost to weather, pests, or disease. Speaking of pests and diseases, bell peppers face a number of challenges in the field. Aphids, small, sap-sucking insects, are among the most common pests of pepper plants. They cluster on the undersides of leaves and on new growth, draining the plant's vitality and excreting a sticky substance called honeydew that promotes the growth of sooty mold. Ladybugs, lacewings, and parasitic wasps are natural enemies of aphids, and encouraging these beneficial insects is an effective and environmentally friendly approach to aphid control. Hornworms, the large, green caterpillars of sphinx moths, can defoliate pepper plants with alarming speed. These impressive larvae, which can grow to 4 inches or more in length, are well camouflaged against the green foliage and can be difficult to spot until they have already done significant damage. Hand-picking is the most straightforward control method for small gardens, while biological controls like Bacillus thuringiensis, BT, can be effective in larger plantings. Flea beetles, tiny, jumping beetles that chew small holes in the leaves, are another common pest. While individual flea beetles do little damage, large populations can riddle the foliage with holes, reducing the plant's photosynthetic capacity and its ability to produce a full crop. Row covers, lightweight fabric barriers placed over the plants, can exclude flea beetles and other insect pests in the early stages of growth. Pepper weevils are a serious pest in some regions. The adult weevils lay their eggs inside developing pepper fruits, and the larvae feed on the seeds and interior flesh, causing the fruit to drop prematurely. Infested fruits often show no external signs of damage, making detection difficult. Crop rotation, sanitation, removing dropped fruits promptly, and monitoring with pheromone traps are important elements of pepper weevil management. Diseases of bell peppers include bacterial spot, caused by species of Xanthomonas, which produces small, dark, water-soaked lesions on leaves and fruits. Phytophthora blight, caused by the water mold Phytophthora capsicum, is a devastating disease that can cause rapid wilting and death of entire plants, particularly in poorly drained soils. Mosaic viruses, transmitted by aphids and other insects, cause mottled, distorted leaves and reduced fruit quality. Powdery mildew, a fungal disease, produces a white, powdery coating on the leaves and can reduce plant vigor and fruit production. Managing these diseases involves a combination of strategies: selecting disease-resistant varieties, rotating crops to prevent pathogen buildup in the soil, managing irrigation to avoid waterlogged conditions, and practicing good sanitation by removing diseased plant material promptly. In some cases, targeted applications of approved pesticides or biological control agents may be necessary. The global production of bell peppers is enormous and growing. Bell peppers and other sweet peppers are cultivated on every inhabited continent in an astonishing range of climates and growing systems, from open field farming in warm Mediterranean climates to high-tech greenhouse production in Northern Europe and East Asia. China is the world's largest producer of peppers, including both sweet and hot varieties. The scale of Chinese pepper production is staggering. The country produces tens of millions of metric tons of peppers annually, dwarfing the production of all other countries combined. Much of this production is consumed domestically, reflecting the enormous importance of peppers in Chinese cuisine. Other major pepper-producing countries include Mexico, Turkey, Indonesia, Spain, Egypt, Italy, and Nigeria. Each of these countries has its own traditions of pepper cultivation and its own preferred varieties. In recent decades, greenhouse production of bell peppers has expanded dramatically, particularly in the Netherlands, Spain, Israel, and Canada. Dutch greenhouse pepper production, in particular, has set the global standard for quality and efficiency, using advanced hydroponic systems, computer-controlled climate management, biological pest control, and lead supplemental lighting to produce high yields of uniformly excellent bell peppers year-round. Greenhouse-grown bell peppers typically command premium prices because of their superior appearance, uniformity, and shelf life. The controlled environment of a greenhouse allows for precise management of temperature, humidity, light, nutrition, and pest pressure, resulting in fruits that are larger, more consistently shaped, and more brightly colored than their field-grown counterparts. The extended growing season in a greenhouse, peppers can be grown year-round with supplemental heating and lighting, also means a more reliable supply for consumers who want bell peppers regardless of the season. Speaking of seasonality, it is worth noting that bell peppers, like all fruits and vegetables, are at their best and at their most affordable when they are in season locally. In temperate climates, the peak season for locally grown bell peppers is typically late summer through early fall, roughly July through October. During this period, peppers are at their freshest, their flavor is at its peak, and prices are at their lowest. Outside of this window, the bell peppers available at the store are typically imported from warmer climates or grown in greenhouses, and while they are still perfectly good to eat, they may not have the same depth of flavor as a pepper picked at the height of summer from a local farm. The harvest of bell peppers is typically done by hand, especially for fresh market peppers where appearance and quality are paramount. Mechanical harvesting has been developed for processing peppers, those destined for canning, freezing, or drying, but the technology has not yet advanced to the point where it can match the selectivity and gentleness of human hands for fresh market fruit. Pickers select peppers based on size, color, and absence of defects, cutting each fruit from the plant with a short length of stem attached. The attached stem helps prolong the pepper's freshness and shelf life. After harvest, bell peppers are typically cooled rapidly to remove field heat, then sorted, graded, and packed for distribution. The ideal storage temperature for bell peppers is about 45 to 50 degrees Fahrenheit with high humidity. At this temperature, bell peppers can maintain good quality for 1 to 3 weeks, depending on the variety and the initial condition of the fruit. Temperatures below 40 degrees can cause chilling injury, manifesting as pitting, water soaking, and decay. This is why you should never store bell peppers in the coldest part of your refrigerator. The CRISPR drawer, set to a moderately cool temperature, is the ideal spot. Let us now explore the culinary world of the bell pepper, the countless ways in which this versatile fruit is prepared and enjoyed in kitchens around the world. Raw bell peppers are a joy to eat. Their crisp, juicy flesh and sweet, slightly fruity flavor make them perfect for snacking, salads, and crudité platters. Red and orange bell peppers, with their higher sugar content, are particularly enjoyable raw. Sliced into strips, they are a favorite dipping vehicle for hummus, ranch dressing, guacamole, and other dips. Their natural cavity makes them ideal edible containers for dips and spreads, A hollowed-out bell pepper filled with herbed cream cheese or spinach artichoke dip makes an impressive and functional party appetizer. In salads, bell peppers add color, crunch, and sweetness. They pair beautifully with leafy greens, tomatoes, cucumbers, onions, and a simple vinaigrette. A chopped bell pepper can elevate a simple green salad from mundane to vibrant. In grain-based salads, tabbouleh, quinoa salad, farro salad, diced bell peppers add freshness and textural contrast. In bean salads, they provide a welcome brightness that balances the earthiness of the beans. Roasting is one of the most transformative and delicious ways to prepare bell peppers. When bell peppers are exposed to high heat, whether over an open flame, under a broiler, or on a hot grill, their skin blisters, chars, and separates from the flesh beneath. The flesh itself softens and concentrates in flavor, becoming silky, sweet, and subtly smoky. After charring, the peppers are typically placed in a bowl and covered. The residual steam loosens the skin further, and then the charred skin is peeled away, revealing the tender, luminous flesh beneath. Roasted bell peppers can be eaten on their own as a side dish, drizzled with olive oil and sprinkled with sea salt. They can be sliced and added to sandwiches, wraps, and pizzas. They can be pureed into sauces, soups, and dips. They can be marinated in olive oil, garlic, and herbs and served as part of an antipasto platter. The possibilities are nearly endless. Stuffed bell peppers are one of the most universally beloved preparations, with versions found in virtually every cuisine that uses bell peppers. The basic concept is simple. The pepper is hollowed out, filled with a savory mixture, and baked until the pepper is tender and the filling is cooked through. But within this simple framework, there is infinite variation. In Mediterranean cuisines, the filling might be a mixture of rice, tomatoes, herbs, and sometimes ground meat. In Mexican-influenced kitchens, the filling might include seasoned ground beef or turkey, rice, black beans, corn, and cheese. In Middle Eastern preparations, the filling might feature rice, pine nuts, currants, and warm spices like cinnamon and allspice. Vegetarian versions abound, with fillings based on quinoa, lentils, mushrooms, tofu, or mixed vegetables. Some recipes top the stuffed peppers with cheese, breadcrumbs, or a sauce before baking. The result in every case is a complete, satisfying meal contained within an edible, beautiful vessel. Stir-frying is another popular method for cooking bell peppers, particularly in Asian cuisines. The high heat of the wok quickly softens the pepper while preserving its bright color and some of its crunch. Bell peppers are a staple ingredient in Chinese, Thai, and Korean stir-fries, where they are combined with meat, tofu, or other vegetables in a savory sauce. The classic Chinese dish of pepper steak, sliced beef stir-fried with bell peppers in a soy-based sauce, is a perfect example of how bell peppers can contribute both flavor and visual appeal to a dish. Grilling bell peppers is a summertime tradition in many parts of the world. Cut into quarters or thick strips, brushed with olive oil, and placed over hot coals or gas flames, bell peppers develop beautiful char marks and a sweet, smoky flavor that is irresistible. Grilled bell peppers are excellent on their own, as part of a grilled vegetable platter, in sandwiches and burgers, or chopped into salsas and relishes. Sautéing bell peppers in a little oil or butter is a quick and easy way to bring out their sweetness and soften their texture. Sautéed peppers are a classic accompaniment to sausages, a key component of fajitas, and a versatile addition to pasta dishes, omelets, and scrambled eggs. The combination of sautéed bell peppers and onions, is such a fundamental pairing that it has become almost a single culinary concept in many traditions. Pickling bell peppers is an age-old preservation technique that extends the shelf life of the fresh harvest and creates a tangy, flavorful condiment. Pickled peppers can be made with a simple brine of vinegar, water, salt, and sugar, sometimes augmented with garlic, herbs, and spices. They are a popular addition to salads, sandwiches, cheese boards, and charcuterie platters. Drying bell peppers concentrates their flavor and creates a versatile pantry staple. While drying is more commonly associated with hot peppers, think dried chili pods, cayenne powder, and paprika, sweet bell peppers can also be dried successfully. Dried bell pepper flakes add color and a mild, sweet flavor to soups, stews, sauces, and spice blends. In industrial food production, dried bell pepper powder is used as a natural flavoring and coloring agent in a wide range of products, from snack seasonings to processed meats. Freezing is perhaps the easiest way to preserve bell peppers for later use. Unlike many vegetables, bell peppers do not need to be blanched before freezing. They can simply be chopped, spread on a baking sheet in a single layer, frozen until solid, and then transferred to a freezer bag or container. Frozen bell peppers lose their crisp texture upon thawing, so they are best used in cooked dishes rather than eaten raw, but they retain their flavor and nutritional value remarkably well. Smoking bell peppers adds yet another dimension of flavor. While the most famous smoked pepper is the chipotle, a smoked, dried jalapeno, sweet bell peppers can also be smoked to delicious effect. Smoked bell peppers can be used in sauces, soups, dips, and anywhere a subtle smoky sweetness is desired. Now let us discuss some specific and beloved bell pepper dishes from around the world, because the global cuisine of bell peppers is a rich and varied tapestry. In Hungary, as we mentioned, the pepper reigns supreme. Chicken paprikash, or csirke paprikas, is a classic Hungarian dish in which chicken pieces are braised in a creamy sauce flavored generously with sweet Hungarian paprika. The dish is typically served over egg noodles or spätzle. Hungarian goulash, or gulyás, is a hearty soup or stew featuring beef, onions, potatoes, and generous amounts of paprika. Lekso, a Hungarian vegetable stew of bell peppers, tomatoes, and onions, often enriched with sausage or eggs, is a summertime staple that celebrates the pepper harvest. In Spain, pimientos del piquillo, small, red, sweet peppers from the Navarra region, are roasted over wood fires, hand-peeled and packed in jars. They are a delicacy that can be stuffed with salt cod, cheese, or meat, or simply enjoyed on their own with a drizzle of olive oil. Romesco sauce from the Catalonia region is a vibrant, nutty sauce made from roasted red peppers, tomatoes, almonds, hazelnuts, garlic, olive oil, and vinegar. It is traditionally served with grilled fish and vegetables, but is versatile enough to accompany almost anything. In Italy, pepernotta, slow-cooked bell peppers with onions and tomatoes, is a beloved side dish or pasta sauce. In southern Italy, frigatelli, small, sweet peppers, are fried in olive oil and served as a simple, addictive snack or side dish. Stuffed peppers, or pepperoni ripieni, are a staple of Italian home cooking, with fillings that vary from region to region and family to family. In Turkey, stuffed peppers, biber dolmasi, are a cornerstone of the cuisine. The Turkish tradition distinguishes between two types of stuffed peppers: those filled with a meat and rice mixture, which are served hot, and those filled with a rice and herb mixture, often with currants and pine nuts, which are served at room temperature. Both are delicious and deeply satisfying. In the Balkans, ajvar, a roasted red pepper and eggplant spread, is a beloved condiment that is made in enormous quantities during the autumn pepper harvest. Families and communities gather to roast peppers over open fires, peel them, and process them into this thick, flavorful spread, which is then canned and enjoyed throughout the winter. The making of ajvar is a social event as much as a culinary one, bringing people together in a celebration of the harvest. In the Middle East, muhammara, a rich, spicy dip made from roasted red peppers, walnuts, breadcrumbs, pomegranate molasses, and spices, is a luxurious addition to any meze spread. It originates from Aleppo, Syria, and is now enjoyed throughout the Middle East and beyond. In North Africa, bell peppers feature prominently in dishes like shakshuka, eggs poached in a sauce of tomatoes, bell peppers, onions, and spices, which has gained enormous global popularity in recent years. The Tunisian salad mechouya, made from grilled bell peppers, tomatoes, onions, and garlic, is a smoky, flavorful condiment served with bread. In Indian cuisine, capsicum, as bell peppers are called in the subcontinent, is used in stir-fries, often combined with potatoes, onions, and spices in a dry curry preparation. Capsicum is also a popular pizza topping in India and features in many Indo-Chinese fusion dishes like capsicum Manchurian, battered and fried bell pepper pieces tossed in a spicy, tangy sauce. In Korean cuisine, green bell peppers and other sweet peppers are often stuffed with a mixture of ground pork and tofu, dipped in egg batter and pan-fried. This dish, called gochujang, is a popular banchan side dish and a comfort food favorite. In Japanese cuisine, bell peppers, called pimon, are a common ingredient in stir-fries and are often stuffed with a mixture of ground meat and onions, then pan-fried and served with a sweet soy glaze. Green bell peppers, despite their slightly bitter flavor, are particularly popular in Japanese cooking. In the Caribbean, bell peppers are an essential component of sofrito, the aromatic base of onions, garlic, peppers, and herbs that forms the foundation of countless Caribbean dishes. Whether it is a Puerto Rican rice and beans, a Cuban ropa vieja, or a Dominican sancocho, sofrito, and by extension, the bell pepper, is almost always present. In Brazilian cuisine, bell peppers appear in moqueca, a fragrant seafood stew, in salads, and in rice dishes. The Brazilian version of stuffed peppers often features a filling of ground beef, rice, tomatoes, and cheese. The sheer diversity of global bell pepper preparations is a testament to the fruit's extraordinary versatility. It can be sweet or savory, raw or cooked, a starring role or a supporting character, a main course or a condiment. Few foods are so universally adaptable. Now let us address some common misconceptions and interesting facts about bell peppers that many people may not know. First, the question of whether a bell pepper is a fruit or a vegetable. Botanically speaking, a bell pepper is unequivocally a fruit, specifically a berry. It develops from the fertilized ovary of a flower and it contains seeds. By the strict botanical definition, any seed-bearing structure that develops from a flower is a fruit. This means that tomatoes, cucumbers, squash, and eggplants are also fruits, botanically speaking. However, in culinary terms, all of these foods, including bell peppers, are treated as vegetables because they are used in savory rather than sweet applications. The fruit versus vegetable debate is, in the end, a matter of perspective. Botany and cuisine simply use different classification systems. Second, there is a widespread belief that you can determine the sex of a bell pepper by counting the number of bumps on its bottom. According to this myth, bell peppers with 3 bumps are male and are better for cooking, while those with 4 bumps are female, sweeter, and better for eating raw. This is entirely false. Bell peppers do not have sexes. The number of lobes, bumps, on a pepper is determined by the number of internal chambers, which is a function of genetics and growing conditions, not gender. Both 3-lobed and 4-lobed peppers can be equally sweet or equally bitter. This myth, while persistent and widely shared on the internet, has no basis in botanical reality. Third, many people do not realize that all bell pepper colors can come from a single species and even a single plant. As we discussed earlier, a green bell pepper is simply an unripe pepper, and it will turn red, yellow, orange, or another color if left on the plant to ripen. Some people dislike green bell peppers because of their slightly bitter, more vegetal flavor and prefer the sweeter, riper colored varieties. This is a perfectly valid preference. The flavor difference between a green and a red bell pepper is real and significant, driven by changes in sugar content and the breakdown of certain bitter compounds during ripening. Fourth, bell peppers are one of the foods most commonly listed on the Dirty Dozen, a list published annually by a well-known environmental organization that identifies the fruits and vegetables with the highest levels of pesticide residues. This listing has led some health-conscious consumers to prefer organic bell peppers, which are grown without synthetic pesticides and fertilizers. Whether the pesticide residues found on conventionally grown bell peppers pose a meaningful health risk is a matter of ongoing debate among scientists and regulators, but for those who wish to minimize their pesticide exposure, choosing organic or growing their own peppers are effective strategies. Fifth, the capsaicin content of bell peppers, while extremely low, is not always precisely 0. Most bell peppers produce no detectable capsaicin, but occasional environmental stress, cross-pollination with a hot pepper variety, or genetic variation can result in a bell pepper with a very mild but perceptible heat. If you have ever bitten into a bell pepper and noticed a faint tingle or warmth, particularly in a green bell pepper, this may be the explanation. However, such instances are rare, and the vast majority of bell peppers are entirely sweet and mild. Let us also discuss the Scoville scale, since it is relevant to understanding the bell pepper's place in the broader pepper family. The Scoville scale, developed in 1912 by pharmacist Wilbur Scoville, is the standard measure of the pungency, heat of peppers and other spicy foods. The scale is based on the concentration of capsaicin and related compounds, measured in Scoville heat units (SHU). A bell pepper with essentially no capsaicin rates at 0 SHU on the Scoville scale. A jalapeno pepper typically ranges from 2,500 to 8,000 SHU. A habanero pepper can reach 100,000 to 350,000 SHU. And the world's hottest peppers, varieties like the Carolina Reaper and Pepper X, have been measured at over 2 million SHU. The bell pepper at the very bottom of this scale is the gentle giant of the pepper world, all size and sweetness, no fire. Now, let us consider some of the potential disadvantages and cautions associated with bell peppers, because no food is perfect for every person in every situation. For most people, bell peppers are a safe and healthful food that can be consumed freely as part of a balanced diet. However, there are some individuals who may need to exercise caution. Allergies to bell peppers, while not among the most common food allergies, do exist. Some individuals experience allergic reactions to bell peppers that can range from mild oral itching or tingling to more severe symptoms like hives, swelling, difficulty breathing, or, in rare cases, anaphylaxis. People who are allergic to other members of the nightshade family, tomatoes, potatoes, eggplants, may be more likely to react to bell peppers as well, due to cross-reactivity between related proteins. Additionally, some people with latex allergy may cross-react with bell peppers, a phenomenon known as latex fruit syndrome. The nightshade issue deserves further discussion. Bell peppers, as members of the Solanaceae family, contain small amounts of compounds called glycoalkaloids, including solanine and related substances. In some nightshade plants, notably the green parts of potato plants, glycoalkaloids can be present at toxic levels. In bell peppers, however, glycoalkaloid levels are extremely low and are not considered a health concern for the vast majority of people. Nevertheless, some individuals, particularly those with certain autoimmune conditions like rheumatoid arthritis, report that eliminating nightshade vegetables from their diet improves their symptoms. The scientific evidence for this is limited and mixed, and most mainstream medical and nutritional authorities do not recommend nightshade elimination for autoimmune patients as a matter of course. However, some individuals do seem to have a personal sensitivity, and for them, reducing or eliminating nightshade consumption, including bell peppers, may provide symptom relief. Digestive sensitivity to bell peppers is relatively common. The skin of the bell pepper, as we mentioned, contains tough cellulose that can be difficult for some people to digest, particularly those with conditions like irritable bowel syndrome, Crohn's disease, or other gastrointestinal disorders. Raw bell peppers may cause bloating, gas, or abdominal discomfort in sensitive individuals. Cooking bell peppers, roasting, sautéing, or stewing softens the cellulose and makes them easier to digest. Peeling roasted bell peppers removes the skin entirely, leaving only the soft, easily digestible flesh. Some people also find that bell peppers cause acid reflux or heartburn, particularly when eaten raw. This may be related to the pepper's acidity or to individual digestive sensitivities. For those who experience reflux after eating bell peppers, cooking them and consuming them in moderate portions may help. Another consideration is that bell peppers are relatively high in certain fermentable carbohydrates known as FODMAPs, fermentable oligosaccharides, disaccharides, monosaccharides, and polyols. For individuals following a low FODMAP diet to manage irritable bowel syndrome, bell peppers, particularly green bell peppers, may need to be consumed in limited quantities. Red bell peppers tend to be lower in FODMAPs than green ones and may be better tolerated. Pesticide residues on conventionally grown bell peppers have been a concern for some consumers. Bell peppers are typically treated with multiple pesticide applications during the growing season to manage the various pests and diseases we discussed earlier. While regulatory agencies set limits on pesticide residues and monitor compliance, some consumers prefer to minimize their exposure by choosing organic peppers or by washing and peeling conventionally grown ones. Washing bell peppers under running water and gently scrubbing them with a soft brush can remove some surface residues, though it will not eliminate residues that have been absorbed into the skin. The environmental impact of bell pepper production is another consideration. Like all agricultural activities, growing bell peppers requires land, water, energy, and inputs like fertilizers and pesticides. Greenhouse production, while it can achieve high yields and reduce pesticide use, is energy-intensive, particularly in northern climates where supplemental heating and lighting are required. The transportation of bell peppers from distant growing regions to consumer markets also has a carbon footprint, especially when the peppers are air freighted. Consumers who are concerned about the environmental impact of their food choices can reduce it by buying locally grown peppers when they are in season, choosing organic or sustainably produced peppers, and reducing food waste by storing and using peppers properly. Let us take a moment to appreciate the remarkable visual beauty of bell peppers, because this is an aspect that is sometimes overlooked in discussions of nutrition and agriculture, but is deeply important to the human experience of food. Bell peppers are quite simply among the most visually stunning of all foods. Their glossy, smooth skin reflects light like polished lacquer. Their colors, true primary colors, and their blends are vivid and saturated in a way that few other foods can match. A red bell pepper is the red of a fire engine, of a ripe apple, of a cardinal in winter. A yellow bell pepper is the yellow of summer sunshine, of a daffodil in spring, of butter melting on warm bread. An orange bell pepper is the orange of an autumn sunset, of a monarch butterfly, of a tangerine segment. And a green bell pepper, the crisp, fresh green of new leaves, of cut grass, of jade. When you slice a bell pepper open, the interior is just as beautiful as the exterior. The clean, pale green or cream-colored walls, the glistening seeds clustered on the placenta, the symmetrical chambers. It is a display of natural architecture that can take your breath away if you stop to really look at it. Chefs and food photographers know this well, which is why bell peppers are among the most frequently photographed and styled foods in the world. This visual beauty is not just aesthetic, it is functional. In the natural world, the bright colors of ripe peppers serve as signals to birds and other seed dispersers, advertising the fruit's ripeness and palatability. In the human world, the bright colors of bell peppers signal nutritional value. The red, orange, and yellow pigments are carotenoids, the same compounds that provide health benefits when consumed. Our attraction to the vibrant colors of bell peppers is, in a sense, an echo of our evolutionary past, when our ancestors' survival depended on their ability to identify nutrient-rich foods in the wild. Artists and still life painters have long recognized the bell pepper as a subject of exceptional beauty. The photographer Edward Weston created a famous series of black and white photographs of bell peppers in the 1920s and 30s, treating them as sculptural forms of extraordinary elegance and sensuality. His Pepper No. 30, taken in 1930, is one of the most celebrated photographs in the history of the medium, a close-up of a bell pepper that reveals the fruit's curves, hollows, and surface textures with an almost transcendent clarity. These photographs demonstrated that extraordinary beauty can be found in the most ordinary, everyday objects, including a common vegetable from the grocery store. Let us also discuss the role of bell peppers in traditional medicine systems around the world, because the healing properties of peppers have been recognized and utilized for millennia. In traditional Mesoamerican medicine, peppers were used to treat a wide range of ailments, from toothaches and earaches to digestive complaints and respiratory problems. The Aztecs used peppers in poultices, infusions, and vapor baths. They recognized that peppers could stimulate appetite, aid digestion, and relieve congestion. These applications were based on centuries of accumulated empirical knowledge, and many of them have been at least partially validated by modern scientific research. In traditional Chinese medicine, peppers, though they arrived relatively recently in the long history of Chinese medicine, have been classified as warming foods that help dispel cold and dampness, stimulate circulation, and promote digestion. They are recommended for conditions associated with coldness and stagnation, such as poor circulation, cold extremities, and sluggish digestion. In Ayurvedic medicine, the traditional healing system of India, bell peppers are generally considered sattvic, pure and balancing, unlike their hot counterparts, which are classified as rajasic or tamasic, meaning they can be overly stimulating or dulling. Sweet bell peppers are considered suitable for all three doshas, constitutional types, when consumed in moderation, and they are valued for their cooling, nourishing properties. In European folk medicine, peppers were used as stimulants, digestive aids, and treatments for rheumatism and muscle pain. The practice of applying capsaicin-containing preparations to the skin for pain relief, which evolved from the use of hot peppers, not sweet bell peppers, has been validated by modern medicine and is the basis of commercially available capsaicin patches and creams used to treat conditions like arthritis, neuropathy, and muscle soreness. While most of these traditional medicinal uses involved hot peppers rather than the mild bell pepper specifically, the sweet bell pepper does offer its own therapeutic benefits through its exceptional nutritional content. The high vitamin C content supports immune function and wound healing. The beta-carotene supports vision and skin health. The antioxidants combat oxidative stress and inflammation. In a sense, eating bell peppers is a form of preventive medicine, a delicious, enjoyable way to provide your body with the nutrients and protective compounds it needs to maintain health and resist disease. Let us now examine some fascinating scientific studies and discoveries related to bell peppers and their compounds. Researchers have studied the antioxidant capacity of bell peppers using a variety of laboratory tests, and the results consistently demonstrate that bell peppers, particularly ripe, colored varieties, have impressive antioxidant activity. Red bell peppers, with their high levels of vitamin C, beta-carotene, and other carotenoids, typically show the highest antioxidant activity, followed by orange and yellow varieties. Green bell peppers, while still nutritious, generally have lower antioxidant activity due to their lower carotenoid and vitamin C content. Studies have also examined the effects of different cooking methods on the nutritional content of bell peppers. Raw bell peppers retain the maximum amount of vitamin C, which is heat-sensitive and water-soluble. Boiling bell peppers results in the greatest loss of vitamin C because the vitamin leaches into the cooking water. Stir-frying, sautéing, and roasting result in moderate vitamin C losses. Steaming and microwaving tend to preserve vitamin C better than boiling because the pepper is not submerged in water. Interestingly, some nutrients in bell peppers actually become more available to the body after cooking. Beta-carotene, for example, is bound within the plant cell structures, and cooking breaks down these structures, releasing the beta-carotene and making it more accessible for absorption. Similarly, adding a small amount of fat, like olive oil, to bell peppers during cooking can significantly enhance the absorption of fat-soluble nutrients like beta-carotene and vitamin E. This is a wonderful example of how traditional cooking methods, like sautéing peppers in olive oil, can be nutritionally superior to eating the food raw, depending on which nutrients you are most interested in maximizing. Research has also explored the potential of bell pepper compounds in cancer prevention. Luteolin, a flavonoid found in bell peppers, has shown promising anti-cancer properties in cell culture and animal studies. It appears to inhibit the growth and spread of cancer cells, induce apoptosis, programmed cell death, and reduce inflammation, all of which are relevant to cancer prevention and treatment. However, it is important to emphasize that these studies are preliminary, and the leap from cell culture results to clinical cancer prevention in humans is enormous. No one should rely on bell peppers or any single food as a cancer treatment or prevention strategy, but incorporating bell peppers and other nutrient-rich vegetables into a varied, balanced diet is a sensible, evidence-based approach to reducing overall cancer risk. The role of bell pepper consumption in eye health has been investigated in several epidemiological studies. Research has found associations between higher dietary intake of lutein and zeaxanthin, both of which are found in bell peppers, and reduced risk of age-related macular degeneration and cataracts. These findings are consistent with the known biological functions of these carotenoids in the eye and provide an additional reason to include bell peppers and other colorful vegetables in the diet. Studies examining the relationship between bell pepper consumption and cardiovascular health have also yielded encouraging results. The potassium, fiber, folate, and antioxidants in bell peppers all contribute to cardiovascular protection through different mechanisms, and diets rich in fruits and vegetables, including bell peppers, are consistently associated with lower rates of heart disease and stroke in population studies. The genome of the bell pepper, the complete set of genetic instructions that tells a pepper plant how to grow, develop, and produce fruit, was fully sequenced in 2014. An international team of researchers published the first complete genome sequence of Capsicum annuum, and the results were revelatory. The pepper genome is enormous by plant standards, approximately 3.5 billion base pairs of DNA, making it larger than the human genome. This massive genome contains over 35,000 protein-coding genes, and much of its bulk is made up of repetitive DNA sequences, transposable elements, sometimes called jumping genes, that have copied themselves throughout the genome over millions of years of evolution. The sequencing of the pepper genome opened up extraordinary new possibilities for understanding and improving bell peppers. For the first time, scientists could identify the specific genes responsible for key traits: sweetness, color, disease resistance, fruit size, wall thickness, shelf life, and of course the absence of capsaicin that defines the bell pepper. The gene responsible for the bell pepper's lack of heat, known as the PUN1 gene, was characterized in detail. Researchers found that the non-functional version of this gene, which bell peppers carry in a homozygous state, prevents the final step in the biosynthesis of capsaicin, effectively disabling the pepper's chemical defense system. This single genetic change, arising from a spontaneous mutation at some point in the pepper's history, is what separates the gentle bell pepper from its fiery relatives. Understanding the genetic basis of traits like color has also been illuminating. The genes controlling the production of chlorophyll, green pigment, carotenoids, red, orange, and yellow pigments, and anthocyanins, purple pigments, have been mapped and studied. The interplay of these genes determines the color of a bell pepper at each stage of ripeness. A green pepper is green because chlorophyll is the dominant pigment. As the pepper ripens, chlorophyll breaks down and carotenoid pigments accumulate. In a red pepper variety, the carotenoids capsanthin and capsorubin dominate, producing the deep red color. In a yellow variety, the carotenoids violexanthin and lutein predominate. In an orange variety, a mix of carotenoids including beta-carotene creates the intermediate hue. The precise genetic regulation of these pigment pathways is complex and is still being unraveled by researchers around the world. The practical applications of this genetic knowledge are significant. Plant breeders can now use molecular markers, specific DNA sequences associated with desirable traits, to accelerate the breeding process. Instead of growing plants to maturity and evaluating their fruit, breeders can test seedlings at the DNA level and identify which ones carry the desired genes before they even flower. This technique, called marker-assisted selection, dramatically reduces the time and expense required to develop new pepper varieties with improved characteristics. Modern bell pepper breeding programs are working on a number of important goals. Disease resistance is a top priority. As we discussed in the first part of our documentary, bell peppers are susceptible to a range of bacterial, fungal, and viral diseases that can devastate crops. Breeders are working to incorporate genes for resistance to these diseases into commercially desirable bell pepper varieties. For example, resistance to bacterial leaf spot caused by Xanthomonas campestris has been identified in certain pepper lines and is being incorporated into new hybrid varieties through traditional crossing and selection, guided by molecular markers. Resistance to Phytophthora capsicum, the oomycete pathogen that causes Phytophthora blight, is another active area of research. This disease is particularly devastating because it can attack all parts of the plant, roots, stems, leaves, and fruit, and it thrives in warm, wet conditions that are also favorable for pepper growth. Complete genetic resistance to Phytophthora capsicum has proven elusive, but partial resistance, which slows disease development and reduces crop losses, has been identified in several pepper lines and is being incorporated into breeding programs. Virus resistance is equally important. Tobacco mosaic virus, cucumber mosaic virus, pepper mottle virus, and various strains of potavirus can cause significant damage to bell pepper crops. Some pepper varieties carry genes that confer resistance to specific virus strains, and these genes are being combined through breeding to create varieties with broad-spectrum virus resistance. The L gene locus, which controls resistance to tobamoviruses, has been particularly well studied and is widely used in pepper breeding programs worldwide. Beyond disease resistance, breeders are working to improve the nutritional quality of bell peppers. While bell peppers are already nutritionally impressive, there is potential to make them even better. Research has identified genetic variation in vitamin C content, carotenoid profiles, and antioxidant activity among different pepper lines, and breeders are working to combine the highest levels of these beneficial compounds with the other traits, size, shape, color, flavor, yield, disease resistance, that define a commercially successful variety. Improving shelf life is another important breeding goal. Bell peppers are perishable products that begin to lose quality soon after harvest. The rate of deterioration is influenced by genetic factors that control the firmness of the fruit wall, the rate of water loss through the skin, and the susceptibility of the fruit to post-harvest diseases. Varieties with thicker, firmer walls and more resistant skin tend to have longer shelf lives, and breeders are selecting for these traits to reduce post-harvest losses and improve the quality of peppers that reach the consumer. Heat tolerance is an increasingly important breeding objective in the context of a changing global climate. As average temperatures rise and heat waves become more frequent and intense, bell pepper crops in many regions are facing greater stress. As we noted in the first part of our documentary, bell peppers are sensitive to extreme heat. Temperatures above 95 degrees Fahrenheit can cause blossom drop and reduced fruit set. Breeders are searching for genetic variation that confers tolerance to high temperatures, allowing plants to continue flowering and setting fruit even during heat waves. Some wild capsicum species, adapted to hot, arid environments, may carry genes for heat tolerance that can be introduced into cultivated bell pepper varieties through interspecific hybridization, crossing between different species within the genus Capsicum. Cold tolerance is also a breeding goal, particularly for extending the growing season in cooler climates. Bell peppers are tropical plants at heart, and they suffer when exposed to temperatures below 50 degrees Fahrenheit. Varieties with improved cold tolerance could be transplanted earlier in the spring and continue producing later into the fall, extending the harvest season and improving yields in regions with short growing seasons. drought tolerance is yet another area of active research. Water scarcity is an increasingly pressing global challenge, and developing crop varieties that can maintain productivity with less water is a critical goal for agriculture worldwide. Some pepper lines show greater ability to maintain growth and fruit production under water-limited conditions, and these lines are being studied and used in breeding programs aimed at developing more water-efficient bell pepper varieties. Let us now turn our attention to the fascinating world of pepper genetics as it relates to flavor, because flavor is, ultimately, why we eat bell peppers. The flavor of a bell pepper is a complex sensory experience that involves taste, aroma, and texture. The sweetness of a bell pepper comes from its sugar content, primarily glucose and fructose, which increases as the pepper ripens. Green bell peppers typically have a sugar content of about 2 to 3%, while fully ripe red bell peppers can contain 4 to 6% sugar or even more. This increase in sweetness during ripening is one of the main reasons why red peppers taste so much better than green ones to most palates, but sweetness is only one component of flavor. Bell peppers also contain organic acids, including citric acid and malic acid, which contribute a subtle tartness that balances the sweetness. The ratio of sugars to acids, the sugar-acid balance, is a key determinant of perceived flavor quality, just as it is in fruits like tomatoes, apples, and grapes. The aroma of a bell pepper, that characteristic, unmistakable scent that you notice when you slice one open, is produced by a complex mixture of volatile organic compounds. Scientists have identified over 170 volatile compounds in bell peppers, including pyrazines, which contribute the green, earthy notes of unripe peppers, terpenes, which contribute floral and fruity notes, aldehydes, esters, and many others. The specific volatile profile changes dramatically as the pepper ripens, which is why a green bell pepper smells quite different from a red one. The distinctive green pepper smell, loved by some and disliked by others, is primarily due to a compound called 2-isobutyl-3-methoxypyrazine, which is present at high levels in unripe peppers and decreases significantly as the pepper matures. Texture is the third pillar of bell pepper flavor. The satisfying crunch of a fresh bell pepper is due to the turgor pressure in its cells, the internal water pressure that keeps the cells firm and rigid. When you bite into a bell pepper, your teeth rupture thousands of individual plant cells, releasing their watery contents and creating the juicy, crisp sensation that makes raw bell peppers so enjoyable. As a bell pepper ages after harvest, it gradually loses water through evaporation, and its turgor pressure decreases, leading to the softening, wrinkling, and eventual limpness that signal a pepper past its prime. Storing peppers in a humid environment and using them promptly after purchase helps maintain that all-important crunch. Let us now explore the economics of the global bell pepper trade, because behind every pepper in the produce aisle lies a vast, interconnected web of growers, shippers, distributors, and retailers. The global trade in bell peppers is worth billions of dollars annually and involves the movement of millions of metric tons of peppers across national borders. Bell peppers are among the most widely traded fresh vegetables in the world, and their trade flows are shaped by geography, climate, economics, and consumer preferences. The Netherlands is one of the most important exporters of bell peppers in the world, despite its small geographic size and northern latitude. Dutch greenhouse technology, among the most advanced in the world, allows for year-round production of high-quality bell peppers in a climate that would otherwise be unsuitable for pepper cultivation. Dutch bell peppers are prized for their uniform size, vibrant colors, and long shelf life, and they are exported throughout Europe and to markets around the world. The Dutch greenhouse sector is a marvel of agricultural engineering, employing closed-loop water recycling systems, carbon dioxide enrichment, biological pest control using beneficial insects, computer-controlled climate management, and increasingly, LED lighting systems that optimize the light spectrum for plant growth and fruit ripening. Spain is another major bell pepper exporter, benefiting from its warm Mediterranean climate and its proximity to the large consumer markets of northern Europe. The Almeria region in southeastern Spain is home to a vast concentration of plastic-covered greenhouses, sometimes called the Sea of Plastic, that produce enormous quantities of tomatoes, peppers, cucumbers, and other vegetables for export. The Almeria model has been extraordinarily successful economically, transforming one of the poorest regions of Spain into one of the wealthiest, but it has also raised environmental concerns related to water use, plastic waste, and labor conditions. Mexico is a major exporter of bell peppers to markets across the continent. The Mexican states of Sinaloa, Sonora, and Baja California are major production areas, benefiting from warm climates, fertile soils, and relatively low labor costs. Mexican bell peppers are available in markets throughout the year, with peak production during the winter and spring months when domestic production in many northern markets is limited. Israel, despite its small size and arid climate, is a significant player in the global bell pepper trade. Israeli agricultural technology, particularly drip irrigation, which was pioneered in Israel, has made it possible to grow high-quality bell peppers in desert conditions with minimal water use. Israeli bell peppers are exported to European markets and are known for their excellent quality. Turkey, a major pepper-producing country, exports significant quantities of both fresh and processed peppers. The Antalya and Mersin regions are major production areas, and Turkish bell peppers are exported to Russia, Europe, and the Middle East. The economics of bell pepper production vary enormously depending on the growing system and the market. Greenhouse production, while it yields higher quality peppers and enables year-round production, requires significant capital investment and ongoing operating costs for heating, cooling, lighting, and labor. Open field production is less expensive per unit area but is subject to the vagaries of weather, pest pressure, and seasonal limitations. The retail price of bell peppers reflects these production costs, as well as transportation, handling, and marketing costs. Green bell peppers are typically the least expensive because they require the shortest growing period and can be harvested from any bell pepper plant. Red, yellow, and orange peppers command premium prices because of the additional growing time and the risk involved in leaving the fruit on the plant to ripen. The pricing of bell peppers can also be influenced by supply and demand dynamics that cause significant price fluctuations throughout the year. Prices tend to be lowest during the peak of the local growing season, when supply is abundant, and highest during the off-season, when peppers must be imported or grown in greenhouses. Weather events, frosts, heat waves, droughts, hurricanes can disrupt production in major growing regions and cause sharp, sudden price increases. The 2021 Texas freeze, for example, damaged crops in northern Mexico and contributed to temporary pepper shortages and price spikes in markets throughout the continent. Let us now consider the environmental dimensions of bell pepper production, the impacts on land, water, and climate, and the opportunities for more sustainable practices. Water use is one of the most significant environmental concerns associated with bell pepper production. Bell peppers are not among the most water-intensive crops, but they do require consistent moisture throughout their growing season, and in arid and semi-arid regions where many peppers are grown, irrigation is essential. The source and sustainability of irrigation water varies widely, from renewable surface water and sustainably managed groundwater to overexploited aquifers and diverted rivers. In some regions, including parts of Spain, Mexico, and the western portions of several continents, bell pepper production is contributing to groundwater depletion and water stress, raising questions about the long-term sustainability of current production practices. Drip irrigation, which delivers water directly to the plant's root zone through a network of tubes and emitters, is the most water-efficient irrigation method for bell peppers and is widely used in modern production systems. Compared to overhead sprinkler irrigation or flood irrigation, Drip irrigation can reduce water use by 30 to 50% while also improving yields and fruit quality. The adoption of drip irrigation in bell pepper production has been one of the most important water conservation advances in modern agriculture. Soil health is another important environmental consideration. Intensive bell pepper production, particularly in monoculture systems where peppers are grown on the same land year after year, can deplete soil organic matter, degrade soil structure, and promote the buildup of soil-borne pathogens. Crop rotation, alternating bell peppers with other crops from different plant families, is one of the most effective strategies for maintaining soil health and breaking pest and disease cycles. Cover cropping, composting, and reduced tillage are other soil-building practices that benefit bell pepper production systems. The use of plastic mulch and row covers in bell pepper production has benefits and drawbacks. Plastic mulch suppresses weeds, conserves soil moisture, and warms the soil, all of which benefit pepper growth and yield. However, the disposal of used plastic mulch is an environmental problem. Most agricultural plastic is not recycled and ends up in landfills or, worse, scattered across the landscape. Biodegradable mulch alternatives are being developed and tested, but they have not yet achieved widespread adoption. Some growers are turning to organic mulches, straw, wood chips, or compost, which decompose naturally and add organic matter to the soil, though they do not provide the same soil-warming benefits as black plastic. Greenhouse production, as we mentioned, is energy-intensive. Heating greenhouses during the winter months in northern climates requires significant amounts of natural gas, propane, or other fuels, contributing to greenhouse gas emissions and climate change. Some innovative greenhouse operations are addressing this challenge by using geothermal energy, waste heat from industrial processes, biomass heating, or heat pump systems powered by renewable electricity. The Dutch greenhouse sector, a global leader in this area, has set ambitious goals for reducing its carbon footprint and is investing heavily in renewable energy and energy efficiency technologies. The carbon footprint of bell peppers, the total greenhouse gas emissions associated with their production, transportation, and distribution, varies widely depending on how and where they are produced. Locally grown, field-produced bell peppers in season have a relatively low carbon footprint. Greenhouse-produced peppers in heated northern greenhouses have a higher footprint due to energy use. And bell peppers that are air freighted from distant growing regions to distant markets have the highest footprint of all, because air freight is an extremely carbon-intensive form of transportation. Consumers who wish to minimize the carbon footprint of their bell pepper consumption can prioritize locally grown, in-season peppers and reduce waste by storing and using peppers before they spoil. Biodiversity is another environmental dimension worth considering. The global trend toward commercial bell pepper production has led to an increasing concentration on a relatively small number of high-yielding, commercially desirable hybrid varieties. This narrowing of genetic diversity raises concerns about vulnerability. A genetically uniform crop is more susceptible to being devastated by a new pest or disease than a genetically diverse one. Maintaining and preserving the genetic diversity of capsicum, including wild species, landrace varieties, and heirloom cultivars, is essential for the long-term resilience and adaptability of pepper agriculture. Seed banks, botanical gardens, and on-farm conservation programs around the world are working to preserve this diversity, but the task is urgent as habitat destruction, climate change, and the replacement of traditional varieties with commercial hybrids threaten to erode the genetic heritage of capsicum. Let us now explore an intriguing area of research, the psychology of bell pepper consumption, including how color influences our perception of taste and how our preferences for different bell pepper colors are shaped by culture, experience, and biology. Color is one of the most powerful influences on our perception of food. Research has consistently shown that people's expectations about how a food will taste are strongly influenced by its color. red foods are expected to be sweet. Green foods are expected to be slightly bitter or sour. Yellow and orange foods are expected to be mild and pleasant. These expectations, while not always accurate, can actually influence the perceived taste of a food, a phenomenon known as the color-flavor expectation effect. When you eat a red bell pepper, your brain has already primed itself to expect sweetness, and this expectation enhances your perception of the pepper's actual sweetness. Conversely, when you eat a green bell pepper, your brain's expectation of bitterness may make you more sensitive to the subtle bitter notes that are actually present. This psychological effect helps explain why red bell peppers are consistently rated as more enjoyable and better tasting than green bell peppers in consumer surveys, even when the actual difference in sugar content is modest. The red color activates positive taste expectations, while the green color activates neutral or slightly negative ones. Of course, the actual chemical differences between green and red peppers, higher sugar, lower pyrazines, more fruity volatiles in the red, reinforce these color-driven expectations, creating a coherent sensory experience. Cultural factors also influence bell pepper preferences. In some culinary traditions, green bell peppers are preferred for their vegetal, slightly bitter flavor, which pairs well with certain dishes and cooking styles. In East Asian cuisines, for example, green bell peppers are widely used in stir-fries, where their firm texture and assertive flavor hold up well against bold sauces and strong aromatics. In other traditions, the sweeter, riper colored peppers are preferred for their compatibility with fresh preparations and lighter cooking methods. Children's preferences for bell peppers are particularly interesting. Many children are initially reluctant to eat bell peppers, particularly green ones, due to a natural developmental tendency toward bitterness sensitivity. Children's taste buds are more sensitive to bitter compounds than adults' taste buds, and this sensitivity is believed to be an evolutionary adaptation that protected young children from accidentally eating toxic plants. As children grow and their taste buds mature, bitterness sensitivity typically decreases, and they become more accepting of foods like bell peppers, broccoli, and Brussels sprouts. Introducing bell peppers in their sweetest, most colorful forms, red, orange, and yellow, can help bridge the gap and encourage children to develop a taste for this nutritious food. The sensory experience of eating a bell pepper is remarkably complex, involving not just taste and aroma, but also touch, sound, and even vision. The crunch of biting into a raw bell pepper produces a distinctive sound, a crisp, satisfying snap that the brain associates with freshness and quality. This auditory component of the eating experience is more important than most people realize. Research has shown that sounds can enhance or diminish the perceived quality of food. Louder, crisper sounds are associated with fresher, more enjoyable textures, while soft, muted sounds signal staleness or deterioration. The bell pepper, with its exceptional crunch, delivers a multi-sensory experience that engages the brain on multiple levels simultaneously. Let us now discuss the role of bell peppers in global food security, a topic of increasing importance as the world's population grows and the challenges of feeding everyone adequately and sustainably become more pressing. Bell peppers, like other fruits and vegetables, play a crucial role in global nutrition. While they are not a significant source of calories or protein, the macronutrients that form the bulk of human energy requirements, they are essential sources of micronutrients, vitamins, minerals, and phytochemicals that are necessary for health and development. Micronutrient deficiencies, sometimes called hidden hunger because they can exist even when calorie intake is adequate, affect billions of people worldwide and contribute to a wide range of health problems, including impaired immune function, increased susceptibility to infection, poor cognitive development in children, and increased risk of chronic diseases in adults. Bell peppers, with their exceptional vitamin C, vitamin A, and antioxidant content, are ideally positioned to address micronutrient deficiencies in populations around the world. A single red bell pepper can provide a full day's requirement of both vitamin C and vitamin A, making it one of the most nutrient-dense foods available. Promoting the consumption of bell peppers and other colorful vegetables is a key strategy in global efforts to combat hidden hunger and improve nutritional outcomes. In developing countries where micronutrient deficiencies are most prevalent, bell pepper cultivation can also provide economic benefits. Bell peppers are relatively high-value crops. They command better prices than staple grains and can generate significant income for smallholder farmers. The labor-intensive nature of pepper cultivation, planting, staking, pruning, harvesting, and packing also means that pepper production creates employment, particularly for women and young people who are often marginalized in other agricultural sectors. However, bell pepper cultivation in developing countries faces significant challenges, including limited access to quality seeds, inadequate irrigation infrastructure, high pest and disease pressure, lack of cold chain facilities for post-harvest handling, and limited access to markets. Addressing these challenges requires investment in agricultural research and extension, infrastructure development, and market linkages, investment that is often insufficient in the regions where it is most needed. Urban agriculture, the practice of growing food in cities and other densely populated areas, represents an exciting frontier for bell pepper production. Bell peppers are well suited to urban growing environments, including rooftop gardens, community gardens, balcony containers, and indoor growing systems. Their compact growth habit, attractive appearance, and high nutritional value make them popular choices for urban gardeners. Indoor growing systems using LED lighting and hydroponic or aeroponic technology can produce bell peppers year-round, regardless of outdoor climate conditions, and they are increasingly being deployed in urban areas as a means of increasing local food production and reducing the environmental footprint of food transportation. Vertical farming, the practice of growing crops in stacked layers inside controlled environment buildings, is another emerging approach to bell pepper production. Vertical farms can produce crops with remarkable efficiency, using up to 95% less water than conventional field agriculture and requiring no pesticides. The controlled environment eliminates weather risk and allows for continuous year-round production. However, the energy requirements of vertical farms, particularly for lighting and climate control, are significant, and the capital costs of building and equipping a vertical farm are high. As renewable energy becomes cheaper and more widely available, and as the technology continues to improve, vertical farming is expected to become an increasingly important component of the global food system. Let us take a moment to explore some of the more unusual and surprising uses of bell peppers that most people may never have considered. Bell pepper seeds, which are usually discarded when the pepper is prepared for cooking, are actually edible and nutritious. They contain small amounts of protein, fat, and fiber, as well as some of the same beneficial phytochemicals found in the pepper's flesh. While they have a slightly bitter taste and a somewhat tough texture, they are not harmful and can be consumed without concern. Some cultures traditionally include the seeds in their pepper preparations, and some health enthusiasts have begun incorporating bell pepper seeds into smoothies and other blended preparations to capture their nutritional benefits. Bell pepper leaves are also edible, though they are rarely consumed in most Western cuisines. In some parts of Asia, particularly in the Philippines, pepper leaves, known as dahan ng sili, are used as a green vegetable in soups and stews. The leaves have a mild, slightly peppery flavor and are a good source of vitamins and minerals. As interest in reducing food waste and making full use of edible plants grows, bell pepper leaves may gain wider recognition as a usable food resource. Bell peppers have been used as natural dyes and colorants for centuries. The pigments in red bell peppers, particularly capsanthin and capsorubin, are powerful natural colorants that can produce vibrant red, orange, and yellow hues. These pigments, extracted from peppers as oleoresin capsicum or paprika extract, are widely used in the food industry to color products ranging from cheese and sausages to snack foods and beverages. They are also used in cosmetics and personal care products to provide natural color to lipsticks, blushes, and other makeup. The growing consumer demand for natural, plant-based colorants, driven by concerns about the safety and aesthetics of synthetic food dyes, is increasing the demand for pepper-derived pigments. Bell peppers have also found applications in the world of crafts and decorations. Dried bell pepper slices can be used in wreaths, garlands, and other decorative arrangements. Their vibrant colors and interesting shapes make them visually appealing, and when properly dried, they can last for months or even years. In some cultures, strings of dried peppers, both sweet and hot, are hung in kitchens as decorative elements that also serve as a convenient pantry supply. The hollow, cup-like shape of the bell pepper has inspired creative uses beyond the kitchen. Bell pepper halves have been used as small planters for sprouting seeds, as candle holders for short tea lights at dinner parties, as serving vessels for individual portions of dip or salsa, and even as stamps for children's art projects. Dipping the cut end of a bell pepper in paint and pressing it onto paper creates a charming, flower-like print that delights children and adults alike. Now let us delve into some more remarkable nutritional and health facts about bell peppers that deserve our attention. The vitamin C content of bell peppers is not just high, it is remarkably stable compared to the vitamin C in many other foods. While vitamin C is notoriously fragile, degrading rapidly when exposed to heat, light, and oxygen, the vitamin C in bell peppers is somewhat protected by the pepper's thick skin and its internal environment. A whole, uncut bell pepper stored in the refrigerator can retain the vast majority of its vitamin C content for a week or more. This stability makes bell peppers a particularly reliable dietary source of vitamin C. You can buy them at the beginning of the week and still receive excellent vitamin C when you eat them several days later. The iron absorption enhancing effect of bell peppers is a nutritional benefit that deserves more attention than it typically receives. Non-heme iron, the form of iron found in plant foods, beans, and fortified foods, is not as readily absorbed by the body as heme iron, the form found in meat. However, vitamin C dramatically enhances the absorption of non-heme iron when the two are consumed together in the same meal. The exceptionally high vitamin C content of bell peppers makes them an ideal food to pair with iron-rich plant foods. Adding sliced bell peppers to a bean salad, a lentil soup, or a spinach salad can significantly increase the amount of iron your body absorbs from the meal. This is particularly important for vegetarians, vegans, and others who rely primarily on plant-based sources of iron. Bell peppers contain a compound called para-coumaric acid, which has been studied for its potential to reduce the risk of stomach cancer. Para-coumaric acid appears to inhibit the formation of nitrosamines, carcinogenic compounds that can form in the stomach when nitrites from processed foods react with amines from protein digestion. By blocking nitrosamine formation, para-coumaric acid may help protect the stomach lining from carcinogenic damage. While more research is needed to confirm this effect in humans, it adds another potential benefit to the already long list of reasons to eat bell peppers. The water content of bell peppers, about 92%, makes them an excellent food for hydration. While drinking water is the primary way to stay hydrated, a significant portion of our daily fluid intake comes from food, and water-rich foods like bell peppers, cucumbers, tomatoes, and watermelon contribute meaningfully to our hydration status. Eating bell peppers on a hot day or after exercise can help replenish fluids and electrolytes, particularly the potassium that is lost through sweat. Bell peppers are remarkably low in oxalates compared to some other vegetables. Oxalates are naturally occurring compounds found in many plant foods that can bind to calcium in the body and contribute to the formation of kidney stones in susceptible individuals. People who are prone to calcium oxalate kidney stones are often advised to limit their intake of high oxalate foods like spinach, beets, and rhubarb. Bell peppers, with their low oxalate content, are generally considered safe for people on low oxalate diets, making them an excellent alternative to higher oxalate vegetables. The folate content of bell peppers is particularly important for women of childbearing age. Folate, also known as vitamin B9, is essential for proper neural tube development in the early stages of pregnancy. Neural tube defects, serious birth defects of the brain and spine, can occur when folate intake is insufficient during the first few weeks of pregnancy, often before a woman even knows she is pregnant. Adequate folate intake before and during early pregnancy significantly reduces the risk of neural tube defects. While prenatal vitamins are an important source of folate for pregnant women, dietary sources like bell peppers contribute to overall folate status and support a healthy pregnancy. Bell peppers have a low allergenic potential compared to many other foods. While bell pepper allergies do exist, as we discussed in the first part of our documentary, they are relatively uncommon. This makes bell peppers a suitable early food for infants being introduced to solid foods, though as with any new food, parents should introduce bell peppers gradually and watch for any signs of an allergic reaction. Cooked, pureed bell peppers are a nutritious and colorful addition to a baby's diet, and their sweet flavor is generally well accepted by young palates. The anti-aging properties of bell peppers have attracted interest from both the scientific community and the beauty industry. The combination of vitamin C, vitamin E, beta-carotene, and other antioxidants in bell peppers provides comprehensive protection against the oxidative damage that contributes to skin aging. Vitamin C, as we discussed, is essential for collagen synthesis, and adequate collagen production helps maintain skin elasticity and firmness. Vitamin E protects skin cell membranes from lipid peroxidation, a form of oxidative damage that contributes to wrinkles and age spots. Beta-carotene provides some natural protection against ultraviolet radiation damage, though it is not a substitute for proper sun protection. Some skincare products now include pepper-derived extracts as active ingredients, capitalizing on the antioxidant and anti-aging properties of bell pepper compounds. Let us now discuss an often overlooked but deeply important aspect of bell pepper culture, the role of heirloom and heritage pepper varieties in preserving agricultural biodiversity and culinary tradition. Heirloom bell pepper varieties are open-pollinated varieties that have been maintained and passed down through generations of gardeners and farmers. Unlike modern hybrid varieties, which are the product of deliberate crosses between two distinct parent lines and which may not breed true from saved seed, heirloom varieties are genetically stable and will produce offspring that closely resemble the parent plant. This means that gardeners can save seed from their heirloom pepper plants and grow the same variety year after year, creating a self-sustaining cycle of cultivation that is independent of commercial seed companies. Heirloom bell peppers come in an astonishing range of shapes, sizes, colors, and flavors. Some are small and blocky, while others are long and tapered. Some are thick-walled, while others have thinner, more delicate flesh. Some are exceptionally sweet, while others have more complex flavor profiles with subtle bitter, earthy, or fruity notes. Some ripen to unusual colors: chocolate brown, deep purple, creamy ivory, or a streaked combination of red and yellow. This diversity is a treasure trove for gardeners, cooks, and plant breeders alike. Among the most celebrated heirloom bell pepper varieties are the bull nose, which is one of the oldest known bell pepper varieties and was described in seed catalogs as early as the 18th century. Its squat, rounded shape and thick, sweet flesh made it a favorite of early gardeners, and it remains popular among heirloom enthusiasts today. The California Wonder, introduced in the 1920s, became the standard bell pepper variety for decades and is still widely grown. Its large, blocky shape and thick walls set the template for the modern commercial bell pepper. The chocolate beauty, with its unusual brown color and sweet, complex flavor, is a favorite among gardeners who enjoy growing unusual varieties. The purple beauty, with its striking dark purple skin, adds visual drama to the garden and the plate. The preservation of heirloom pepper varieties is not just a matter of nostalgia or aesthetic preference, it is a critically important contribution to agricultural biodiversity. Every heirloom variety represents a unique combination of genes, adapted to specific growing conditions and culinary purposes over many years of selection. These genetic resources may contain traits, disease resistance, heat tolerance, drought tolerance, unique flavors, unusual nutritional profiles that are not present in modern commercial varieties, but that may prove invaluable in the future as growing conditions change and new challenges emerge. Seed-saving organizations, community seed libraries, and dedicated heirloom gardeners play a vital role in preserving this genetic heritage. By growing heirloom varieties, saving their seeds, and sharing them with others, they maintain a living library of genetic diversity that enriches our food system and safeguards our ability to adapt to future challenges. Let us now travel around the world one more time, visiting some of the most distinctive and fascinating bell pepper traditions that we did not have time to explore in the first part of our documentary. In the Basque Country, straddling the border between France and Spain, the Espelette pepper has achieved legendary status. While not technically a bell pepper, it is a mildly hot variety of Capsicum annuum. The Espelette pepper exemplifies the deep cultural connections that can form between a community and its local pepper variety. Every autumn, the whitewashed buildings of Espelette village are draped with garlands of drying red peppers, creating a visual spectacle that attracts visitors from around the world. The Espelette pepper has been awarded Appellation d'origine contrôlée, AOC status, the prestigious French designation that recognizes and protects foods with a unique connection to their place of origin. This designation ensures that only peppers grown in the designated area, using traditional methods, can bear the Espelette name. In the Balkans, as we mentioned, the autumn pepper harvest is a major cultural event. In Serbia, North Macedonia, and other Balkan countries, families gather in late September and October for the annual ajvar making ritual. Huge quantities of red bell peppers are roasted over open fires, the smoke and aroma filling the air for miles around, then peeled, chopped, and slowly cooked with eggplant and oil into the thick, rich spread known as ajvar. Families make ajvar in quantities measured in dozens of jars, enough to last through the winter. The process is social and communal, bringing together families, neighbors, and friends in a celebration of the harvest that reinforces social bonds and cultural identity. Ajvar has become a symbol of Balkan identity, and the annual ajvar making season is recognized as an important intangible cultural heritage. In the Sichuan province of China, while the focus is primarily on hot peppers rather than sweet ones, the broader pepper culture has influenced the use of all capsicum varieties. Sweet bell peppers, known as qingjiao, green pepper, or kaijiao, vegetable pepper in Mandarin Chinese, are widely used in Chinese home cooking and restaurant cuisine. One of the most popular Chinese bell pepper dishes is hu pai qingjiao, tiger skin green peppers, in which whole green bell peppers are charred in a very hot wok until their skin blisters and blackens in spots resembling tiger stripes, then seasoned with soy sauce, vinegar, and garlic. The charring transforms the flavor of the green pepper, mellowing its bitterness and adding a smoky complexity that is deeply satisfying. In the Philippines, bell peppers are an important ingredient in many dishes, including the beloved macado, a tomato-based beef stew, afritada, chicken or pork stewed with tomatoes and bell peppers, and menudo, a pork and liver stew with bell peppers, tomatoes, and potatoes. The use of bell peppers in Filipino cuisine reflects the layered culinary influences of Malay, Chinese, Spanish, and other traditions that have shaped this vibrant food culture. In Ethiopian cuisine, while the focus is typically on hot peppers used in Berber spice blends and various stews, Green bell peppers are used in fresh salads and in tibs, sautéed meat dishes that combine bell peppers with onions, tomatoes, and spices. The contrast between the fiery heat of the spice blends and the cool sweetness of the fresh bell peppers creates a dynamic and balanced eating experience. In Peruvian cuisine, one of the most celebrated and diverse cuisines in the world, peppers of all kinds play a central role. The ají amarillo, yellow pepper, ají panca, dark red pepper, and recodo, a hot, apple-shaped pepper, are pillars of Peruvian cooking. While these are not bell peppers per se, the Peruvian culinary philosophy of building dishes around the unique flavor profiles of different pepper varieties has influenced how bell peppers are used when they are included in Peruvian-inspired cooking. In Nigerian cuisine, bell peppers, known as tatash, are an essential ingredient in the stew base that forms the foundation of many Nigerian dishes. Tatash refers specifically to large, red bell peppers, which are blended with tomatoes and hot peppers to create a rich, flavorful puree that is fried in oil and used as the sauce for rice, yam, meat, and fish dishes. The combination of sweet bell peppers, fresh tomatoes, and hot peppers, known as the pepper mix or base, is so fundamental to Nigerian cooking that it is prepared in large batches and stored for use throughout the week. Let us now discuss some of the more unexpected and creative modern uses of bell peppers in contemporary cuisine and food culture. The bell pepper boat has become a popular concept in modern healthy cooking. By cutting a bell pepper in half lengthwise and removing the seeds and membranes, you create a natural, edible vessel that can be filled with almost anything: taco meat, pizza toppings, egg mixtures for baking, grains and vegetables, or even dessert fillings. Bell pepper boats are popular among health-conscious eaters who are looking for low-carbohydrate alternatives to bread, tortillas, and pasta. A bell pepper filled with seasoned ground meat, cheese, and salsa can satisfy the craving for a taco without the carbohydrate load of a traditional tortilla. A bell pepper half filled with eggs, cheese, and vegetables can be baked into a satisfying, grain-free breakfast. Bell pepper nachos, sliced bell peppers used in place of tortilla chips, topped with ground meat, cheese, beans, and other nacho toppings, have become a viral recipe on social media, appealing to those following low-carb, ketogenic, or grain-free diets. The crisp texture of the bell pepper slices provides a satisfying crunch that mimics the function of the chip, while the sweet flavor of the pepper complements the savory toppings beautifully. Bell pepper juice has gained popularity in the health and wellness community. Raw bell peppers, particularly red ones, can be juiced to produce a sweet, mild, brightly colored juice that is rich in vitamin C and other nutrients. Bell pepper juice is often combined with other vegetable and fruit juices, carrot, apple, ginger, celery, to create nutrient-dense beverages. While the health benefits of juicing are sometimes overstated by enthusiasts, there is no question that a glass of fresh bell pepper juice is a concentrated source of vitamins and antioxidants. Bell pepper powder, made by dehydrating and grinding bell peppers, is a versatile pantry staple that deserves wider recognition. Red bell pepper powder has a sweet, mild, fruity flavor that can be used as a seasoning for meats, vegetables, soups, sauces, and snacks. It adds both color and flavor and can serve as a milder alternative to paprika in recipes where a less intense pepper flavor is desired. Green bell pepper powder, while less common, has a distinctive vegetal flavor that can be interesting in certain applications. Making bell pepper powder at home is straightforward. Simply slice bell peppers thinly, dehydrate them in a food dehydrator or a low oven, and grind the dried slices to a powder in a spice grinder. Bell pepper fermentation is an area of growing interest among fermentation enthusiasts. Fermented bell peppers, made by submerging sliced or chopped bell peppers in a saltwater brine and allowing them to ferment for several days to several weeks, develop a tangy, complex flavor and a softer texture. The fermentation process also produces beneficial bacteria, probiotics, that support gut health and digestion. Fermented bell peppers can be eaten on their own as a condiment, added to salads and sandwiches, or blended into sauces and dressings. Bell peppers have also found their way into dessert applications, though this remains a niche and somewhat adventurous use. Red bell pepper can be incorporated into fruit sorbets, adding a subtle vegetal depth to the sweetness. Bell pepper jam or jelly, often made with a combination of bell peppers, sugar, vinegar, and pectin, is a popular condiment in some regions, served with cream cheese on crackers as an appetizer or used as a glaze for roasted meats. Bell pepper cake and bell pepper ice cream exist as novelty items in some culinary traditions, demonstrating the remarkable versatility of this ingredient. Let us now look to the future of bell peppers, the trends, technologies, and challenges that will shape how this remarkable fruit is grown, distributed, and consumed in the decades ahead. Climate change is perhaps the most significant challenge facing bell pepper production globally. Rising temperatures, altered precipitation patterns, more frequent extreme weather events, and shifting pest and disease dynamics all threaten to disrupt pepper production in established growing regions. Heat stress, as we discussed, can cause blossom drop and reduced fruit set, potentially reducing yields in regions that are already close to the upper temperature limit for optimal pepper production. Drought, exacerbated by changing precipitation patterns and increased evaporation rates, threatens water supplies in many important pepper-growing regions. Conversely, increased rainfall and flooding in some areas can promote soil-borne diseases and create challenging growing conditions. Adaptation to climate change will require a multi-pronged approach. Breeding heat-tolerant and drought-tolerant pepper varieties, as we discussed, is a key strategy. Improving water management through drip irrigation, mulching, soil moisture monitoring, and deficit irrigation strategies will be essential for maintaining production in water-scarce regions. Shifting production to new geographic areas that may become more suitable for pepper cultivation as the climate changes is another possibility, though this raises its own challenges related to infrastructure, labor, and market access. Protected cultivation, growing peppers in greenhouses, high tunnels, and other controlled environments, offers a buffer against climate variability and extreme weather events. While the energy costs of protected cultivation are a concern, advances in renewable energy, energy-efficient greenhouse design, and climate-adaptive growing technologies are steadily reducing these costs. The integration of photovoltaic panels into greenhouse structures, so-called agrivoltaic systems, is an emerging technology that promises to generate renewable electricity while also providing partial shade for crops, potentially benefiting heat-sensitive plants like bell peppers. Precision agriculture technologies, including GPS-guided planting and harvesting, drone-based crop monitoring, soil and plant sensors, and data-driven decision-making tools, are increasingly being applied to bell pepper production. These technologies allow growers to apply water, fertilizers, and pest management inputs more precisely and efficiently, reducing waste, lowering costs, and minimizing environmental impact. As these technologies become more affordable and accessible, they are expected to transform pepper production at all scales, from large commercial operations to smallholder farms. Robotic harvesting is an area of active research and development that has the potential to address labor shortages in the pepper industry. Harvesting bell peppers by hand is labor-intensive and physically demanding, and finding sufficient workers during the harvest season is an ongoing challenge for growers in many regions. Several companies and research institutions are developing robotic pepper harvesters that use computer vision, artificial intelligence, and robotic arms to identify ripe peppers, assess their quality, and harvest them without damaging the plant or the fruit. While current prototypes are not yet as fast or as selective as skilled human pickers, the technology is advancing rapidly, and commercial robotic pepper harvesters may become a reality within the next decade. Gene editing technologies, particularly CRISPR-Cas9, represent a potentially transformative tool for bell pepper improvement. Unlike traditional genetic modification, which involves inserting genes from unrelated organisms. Gene editing allows scientists to make precise, targeted changes to a plant's existing genes. This could enable the rapid development of pepper varieties with improved disease resistance, enhanced nutritional quality, better shelf life, or improved adaptation to challenging growing conditions. Gene-edited crops are subject to different regulatory frameworks in different countries, and the social acceptability of gene editing in food production remains a topic of public debate. However, the potential benefits, particularly for addressing the challenges of climate change and food security, are significant. The trend toward plant-based diets is likely to increase demand for bell peppers and other vegetables in the coming years. As more consumers reduce their meat consumption for health, environmental, or ethical reasons, they are looking for flavorful, satisfying, nutritious plant foods to fill the gap. Bell peppers, with their vibrant colors, versatile culinary applications, and impressive nutritional profile, are ideally positioned to benefit from this trend. Plant-based meat alternatives, which often struggle with flavor and texture, could potentially incorporate bell pepper extracts or derivatives to improve their taste and nutritional value. The global demand for organic bell peppers is growing steadily, driven by consumer concerns about pesticide residues, environmental sustainability, and food quality. Organic pepper production, which prohibits the use of synthetic pesticides and fertilizers, typically commands premium prices and can provide higher returns for farmers. However, organic pepper production also faces challenges, including higher pest and disease pressure, lower yields in some cases, and the need for more labor-intensive management practices. Advances in biological pest control, organic approved crop protection products, and integrated pest management are helping to address some of these challenges and make organic pepper production more viable and more widely practiced. The development of functional foods and nutraceuticals based on bell pepper compounds is another emerging trend. As scientific understanding of the health benefits of bell pepper phytochemicals grows, there is increasing interest in developing concentrated extracts, supplements, and fortified foods that deliver the beneficial compounds of bell peppers in higher doses or more convenient forms. Capsicum-rich extracts, for example, are being investigated for their potential antioxidant and anti-inflammatory benefits. Lutein and zeaxanthin supplements derived from pepper sources could compete with existing supplements derived from marigold flowers. While whole bell peppers will always be the best way to obtain their health benefits, because of the synergistic interactions among their many compounds, these derivative products may offer additional options for consumers seeking targeted health benefits. Food waste reduction is another area where bell peppers intersect with broader sustainability trends. An estimated 30 to 40% of all food produced globally is wasted, and fruits and vegetables, including bell peppers, are among the most frequently wasted food categories. Bell peppers are wasted at every stage of the supply chain. In the field, cosmetically imperfect peppers that are not harvested; at the packing house, peppers that do not meet size, shape, or color standards; at the retail level, peppers that are not sold before they lose their visual appeal; and at the consumer level, peppers that are purchased but not consumed before they spoil. Addressing this waste requires action across the entire supply chain, from breeding varieties with longer shelf life to developing markets for imperfect produce, to educating consumers about proper storage and use of bell peppers. Ugly Produce initiatives, programs that sell cosmetically imperfect fruits and vegetables at discounted prices, have gained traction in recent years and can help reduce waste of bell peppers that are perfectly nutritious and delicious, but do not meet the rigid cosmetic standards of traditional retail markets. A bell pepper with an unusual shape, A minor blemish or a slightly smaller size tastes just as good and provides the same nutritional benefits as a picture-perfect specimen, and selling these peppers rather than discarding them is both economically and environmentally beneficial. Let us now take a few moments to share some of the most surprising and little-known facts about bell peppers, the kind of facts that make you look at this familiar food with fresh eyes and renewed appreciation. Bell peppers float in water. Because of the large air-filled cavity inside them, whole bell peppers are buoyant and will float when placed in a bowl or sink full of water. This simple physical property has practical applications. Floating peppers in a basin of cold water is an effective way to cool them quickly after roasting, and the buoyancy of peppers can be used as a simple test of freshness. A very fresh pepper with its cells fully turgid with water will float high in the water, while a dehydrated, aging pepper will float lower or, if severely shriveled, may even sink. Bell peppers can be grown upside down. Hanging planters that support the pepper plant from above, with the stems and fruit dangling downward, have been developed for space-limited urban gardens. While not ideal for maximum production, upside-down pepper growing is a viable and entertaining approach that can work well on balconies, patios, and other small spaces. The world record for the largest bell pepper ever grown is a subject of periodic competition among gardeners, with specimen peppers sometimes weighing over 1 pound. These giant peppers are typically grown using intensive cultivation techniques, abundant water, heavy fertilization, and careful pruning to direct the plant's energy into a single fruit. Bell peppers can cross-pollinate with hot peppers if the two are grown in close proximity. This means that if you grow a bell pepper plant next to a jalapeno plant, and bees carry pollen from the jalapeno to the bell pepper flowers, the resulting seeds could produce plants that bear peppers with some heat. The cross-pollination does not affect the current season's fruit. The bell peppers on the plant will still be sweet. But if you save seed from those peppers and plant them the following year, you might be surprised to discover that some of the offspring produce fruits with unexpected spiciness. This is one reason why seed savers who want to maintain the purity of their pepper varieties take care to isolate different varieties from each other during the flowering period. Bell peppers respond to music and sound vibrations. While this claim has been the subject of much popular interest and some scientific inquiry, the evidence is mixed. Some studies have suggested that plants exposed to certain sound frequencies may grow faster or produce more fruit, while other studies have found no significant effect. The idea that talking to your pepper plants or playing them classical music will improve your harvest is charming but not conclusively supported by scientific evidence. What is well established, however, is that the vibrations produced by bees and other pollinators buzzing around the flowers do enhance pollination through a process called buzz pollination. The vibrations cause the flower's anthers to release pollen more readily. Bell peppers change color on the plant, but they do not continue to ripen significantly after harvest. Unlike bananas, avocados, or tomatoes, which are climacteric fruits that continue to ripen after being picked, bell peppers are non-climacteric. Their ripening process essentially stops when they are separated from the plant. A green bell pepper that is harvested will remain green and will not turn red, no matter how long you wait. It may soften and eventually spoil, but it will not undergo the color and flavor changes that occur during on-vine ripening. This is why it is important to harvest colored bell peppers at the desired stage of ripeness, because there is no opportunity for further ripening after harvest. The world consumes an estimated 36 million metric tons of peppers annually, including both sweet and hot varieties. This enormous figure reflects the universal popularity of peppers across cultures and cuisines. If you were to pile all the bell peppers consumed in a single year into a single mountain, it would be a structure of almost unimaginable scale, a monument to humanity's love affair with this remarkable fruit. Bell peppers have been taken into space. Peppers, including a capsicum variety closely related to the bell pepper, have been grown on the International Space Station, as part of experiments investigating the feasibility of growing fresh food in the microgravity environment of space. The successful cultivation of peppers in space is a significant milestone for long-duration space missions, where providing astronauts with fresh, nutritious food will be essential for maintaining health and morale during journeys lasting months or years. The scent of bell peppers has been studied by perfumers and flavor scientists for its complex, distinctive character. The green, slightly earthy aroma of fresh bell peppers, primarily due to the compound 2-isobutyl-3-methoxypurazine, is used in some perfumes and fragrances, typically in very small quantities to add a fresh, vegetal note. This compound is extraordinarily potent. It can be detected by the human nose at concentrations as low as 2 parts per trillion, making it one of the most potent aroma compounds known to science. This extreme potency explains why even a small amount of green bell pepper can dominate the aroma of a dish. Bell peppers have been the subject of artistic and cultural symbolism in various traditions. In some cultures, the bell pepper symbolizes prosperity and good fortune, perhaps because of its plump, generous shape and its association with abundance and harvest. In others, it represents diversity and variety because of the wide range of colors and forms it can take. The bell pepper has appeared in paintings, sculptures, poems, and songs around the world, its distinctive shape and vibrant colors making it a natural subject for artistic expression. Let us now wrap up this incredible story with a synthesis of all that we have covered. The bell pepper is far more than a simple vegetable. It is a biological marvel, a fruit that evolved a chemical defense system based on capsaicin, only to have a subset of its offspring lose that defense through a chance genetic mutation, giving rise to one of the sweetest, mildest, and most versatile foods in the human diet. It is a historical traveler, a plant that originated in the ancient tropical forests of the Western Hemisphere, was domesticated by indigenous peoples thousands of years before European contact, crossed the Atlantic in the holds of Spanish ships, and spread to every inhabited continent within a few decades, reshaping cuisines and cultures as it went. It is a nutritional powerhouse, one of the richest food sources of vitamin C on the planet, loaded with vitamin A, vitamin E, vitamin B6, folate, potassium, and a dazzling array of antioxidant phytochemicals that protect against heart disease, cancer, eye disease, and aging. It is a culinary chameleon, equally at home raw in a salad, roasted over an open flame, stuffed and baked, stir-fried in a wok, pickled in vinegar, fermented in brine, or ground into a powder. It is a feast for the eyes, its glossy skin and vivid colors making it one of the most visually stunning foods in any market or kitchen. It is a crop of enormous economic importance, generating billions of dollars in trade, supporting the livelihoods of millions of farmers and workers, and providing essential nutrition to billions of consumers. It is a subject of cutting-edge scientific research, its genome mapped, its genes characterized, its compounds studied for their potential to prevent and treat disease. And it is a symbol of agricultural heritage, its heirloom varieties preserving the genetic diversity and cultural traditions of communities around the world. The story of the bell pepper reminds us of some fundamental truths about food and our relationship with it. It reminds us that every food has a history, a long, complex, often surprising story of origin, dispersal, adaptation, and transformation. It reminds us that the foods we take for granted, the ones that sit quietly in our refrigerators, the ones we slice without a second thought, are the products of millennia of natural evolution and human ingenuity. It reminds us that nutrition is not just about macronutrients and calories, but about the thousands of chemical compounds in whole, natural foods that work together in ways we are only beginning to understand. It reminds us that cooking is not just a chore, but a creative act, a way of connecting with the cultures and traditions that have shaped the food on our plates. It reminds us that agriculture is not just an industry, but a living, evolving relationship between humans and the plants and animals that sustain us. and it reminds us that even the most humble, everyday food can be a source of wonder, beauty, and inspiration, if only we take the time to look at it closely. The bell pepper has traveled an extraordinary journey to reach your plate. It has crossed oceans and continents. It has passed through the hands of ancient farmers, colonial explorers, immigrant gardeners, and modern scientists. It has been roasted over open fires in the Balkans, stir-fried in woks in Sichuan, stuffed in kitchens in Turkey, juiced in health bars in Sydney, and sliced into lunch boxes in Tokyo. It has been offered to the gods by the Aztecs, studied in laboratories by Nobel Prize-winning chemists, grown in greenhouses by the Dutch, and cultivated in space by astronauts. And now it sits on your cutting board, glossy and vibrant, waiting to nourish you, waiting to delight you, waiting to connect you to a story that stretches back 10,000 years and reaches forward into a future of innovation, discovery, and hope. So the next time you reach for a bell pepper, whether it is a deep, luscious red, a sunny golden yellow, a vibrant orange, or a crisp, fresh green, pause for just a moment. Hold it in your hand. Feel its weight, its smoothness, its cool solidity. Look at the way the light plays across its surface. Smell that faint, distinctive aroma. And remember that you are holding something extraordinary, not just a vegetable, not just a fruit, but a living piece of history, a masterpiece of natural engineering, a gift from the earth to the table. The bell pepper asks very little of us, a little sunshine, a little water, a little patience. In return, it gives us beauty, it gives us flavor, it gives us crunch and sweetness and color and joy. It gives us vitamin C and carotenoids and antioxidants and fiber. It gives us a canvas for our creativity in the kitchen. It gives us a connection to the earth and to the cultures that have come before us. It gives us, in short, far more than we could ever give it in return, and that perhaps is the greatest fact of all. The bell pepper is a humble food with an extraordinary story. It is a small fruit with a big impact. It is a quiet presence in the kitchen with a loud voice in the history of food. It has shaped cuisines, inspired scientists, nourished billions, and delighted palates across every culture and every continent on Earth. From the wild jungles of its ancient homeland to the gleaming greenhouses of the modern world, from the clay pots of the Aztecs to the cutting boards of today, the bell pepper has been a constant companion on humanity's culinary journey. It has adapted to every climate, every culture, every cuisine. It has been reinvented 1,000 times, and yet it has never lost its essential nature: sweet, crisp, colorful, generous, and endlessly versatile. The story of the bell pepper is not over. New varieties are being bred, new growing technologies are being developed, new culinary applications are being imagined, new scientific discoveries are being made. The next chapter of the bell pepper's story is being written right now, in fields and greenhouses and kitchens and laboratories around the world. And you, every time you buy a bell pepper, every time you slice one open, every time you take that first crisp, sweet bite, you are part of that story. You are the latest link in a chain that stretches back to the very dawn of agriculture. You are carrying forward a tradition that connects you to ancient farmers, intrepid explorers, creative cooks, and brilliant scientists. You are part of the story of the bell pepper, and what a remarkable story it is. Thank you for joining us on this incredible journey through the history, science, culture, and cuisine of one of the world's most beloved foods. We hope that this documentary has given you a new appreciation for the bell pepper, a food that is so familiar, so ordinary, and yet so extraordinary in every way. Remember to share this video with your friends and family who love food, history, and the wonders of the natural world. Leave a comment telling us your favorite way to enjoy bell peppers, whether you prefer them raw, roasted, stuffed, grilled, pickled, or prepared in some other way we have not even mentioned. Tell us which facts surprised you the most, tell us which bell pepper color is your favorite, and tell us what food you would like us to explore in our next documentary. Until then, keep eating your bell peppers, keep exploring the incredible world of food, and keep asking the questions that led to the most delicious answers. This has been the complete story of the bell pepper, from seed to plate, from ancient forest to modern table, from wild fruit to global staple. From forgotten mutation to nutritional superstar, the bell pepper, simple, beautiful, extraordinary.